money sponsored by Sri K. Shataranand sir. So we will start with the praise song.
And I'm not audible.
Hello sir.
Not audible. Keep it closer.
Hey sir. Money sponsored Suta Satimati Paragela Saraswati Murari Suta Satimati Paragela Saraswati Murari Suta Satimati Paragela Saraswati Murari Suta Satimati Paragela Saraswati Viranana Amba Viranana Amba Viranana Amba Viranana Vanano Sangu Parapari Daya Kari Sanidani Damagasa Nidanisa Gamadani Salsani Dadani Mamagasa Sanida Danisa Magama Nilani Sanida Madani Sari Sani Sani Dani Damadani Paragela Saraswati Sega Sega Dulagallanu Pranodhyumpa Taramugani Sega Sega Dulagallanu Pranodhyumpa Taramugani Purani Amba Purani Amba Purani Dharajutaku Smaratunu Sarojamukhi Sanidani Ramagasa Nidanisa Gamadani Sasani Dadani Mamaga Sasani Dadani Magama Nidani Sani Damadani Sani 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 Dani Damadani Paragila Saraswati. Thank you. Thank you, Dinesh. Sir, this second day seminar theme is environmental geophysics. So we have first plenary talks. After the plenary talks, we will move. We have two lecture halls. This is the lecture hall 1, and the first year classroom is the second lecture hall 2. So after completion of the plenary session, we will split the audience also. So now I request Professor R.R. Rao sir, outstanding scientist, retired from DRDO. Please come onto the dais and for taking out the chair for the proceedings of this session. And also now I request Dr. R. Mahesh, scientist F, NRSC Hyderabad, come onto the dais and taking out the chair for conducting the proceedings.
How much time we have for the session? How much time we have for the session? 2 talks. Each talk for about half an hour or 20 minutes. How much time we have in session?
25 minutes. Regular that.
Good morning, one and all. I hope you have a wonderful day yesterday. Today, let us start with our plenary talks. There are two talks. Unfortunately, two talks could not be present. The first talk is by Dr. D. Srinivas. He is from IG CAR, a very eminent scientist. He is going to talk on recent advances in weather for predictions for emergency response and disaster management at IG CAR. IG CAR is Indira Gandhi Center for Atomic Research at Kalpakkam. Dr. Srinivas. Please come. All to you. You have 25 minutes for presentation, 5 minutes for discussion. Yeah. Okay. Dr. C. Srinivas is a senior scientist at Indira Gandhi Center for Atomic Research, Kalpakkam. He completed his MSc in meteorology in 1989 and PhD from Andhra University, Visakhapatnam in 2001. He was a postdoctoral research fellow at Department of Meteorology, Johnson State University during 2006-2008. He has contributed to in regional scale atmospheric modeling, effectively used dynamical atmospheric models and observations to study a range of nonlinear scale interacting systems such as boundary layer rolls, mesoscale and topographic flows, convective storms and tropical cyclones for the realistic prediction simulation by testing the physical process representation and data assimilation. He has contributed for the development of emergency response decision support systems for nuclear and chemical emergencies using weather prediction and atmospheric dispersion models. He has pursued several research projects. He has contributed over 150 publications in peer-reviewed international journals and 7 book chapters. Currently, he is serving as head Environmental Assessment Division, IG CAR. He is instrumental in establishing C-band polar metric Doppler weather radar and mid-tropospheric wind profiler radar facilities at IG CAR for atmospheric studies in collaboration with ISRO. He is also a professor of Homi Bhabha National Center and guided PhDs for 10 MTech and MSc students.
Because am I audible? No, not audible. Audible. It's not picking up. Mic is not picking up. Hello. Hello. Thank you, sir. Thank you, sir. So before I begin my talk, I express my thanks to the organizers of this great event, Advances in Geophysics for the Sustainable Future, Energy, Environment, and Natural Resources, being conducted by before I begin my talk, I give my thanks to the organizers behind all the organizers of this great event. National Seminar and Advances in Geophysics for Sustainable Future, Energy, Environment, and Natural Resources. No, sir, it is not audible. Is it audible? Is it audible? Am I audible, sir, now? So I begin my talk on this. Thank you, sir. Thank you very much. I'm very happy to see a large gathering of our students of this department, of Geophysics, which has a history of 75 years. And incidentally, I also happen to be a student of this Department of Meteorology and Oceanography. In 1989, I completed my PhD. Later, I completed my PhD. And I also happen to have taken a few courses from this great department. And I sincerely convey my regards to all the senior faculty members of this great department, and also the faculty of the Department of Meteorology. And I feel very honored, privileged to have come to this event. And today I present on the topic recent progress in weather predictions for emergency response and disaster management at Indira Gandhi Center for Atomic Research, Kolkata. The nuclear energy status in India, environmental safety, emergency response program, and online by IGCAR. What is the need for reliable weather forecast? That is the topic of my presentation. And changes for the increasing demands of nuclear energy demands involves using the natural uranium in pressurized heavy water reactors. And in the second stage, the development and use of the fast feeders using the depleted uranium from the first stage. And a breeder reactor is a reactor where we produce more fuel than it consumes by breeding the fissile nucleus, and which will so the third stage involves the utilization of the thorium, mainly uranium-233 by auxiliary plutonium. And this program aims to not only meet the energy demands of the country, to reduce the carbon loads into the atmosphere, because this is one of the green one of the technologies which emit a very low emissions of carbon dioxide without consuming any fossil fuels. Next. So as of now, we have 24 reactors and producing energy of around nearly 8.8 gigawatts of power. And these nuclear reactors are various technologies and set up at various locations like Kudankulam, Rajasthan, Kattapara, Tarapur, and many other locations. Many more reactors are under construction and which are being commissioned in the coming years. And now, very recently, the nuclear power program is being scaled up, and it is projected that the present power production will be scaled by nearly 10 times in the coming 10 years. Next. When it comes to the nuclear radiations, we are always feared about the radiations. The main the fear for the radiation is the Japanese bomb explosions, which happened unfortunately in the history of nuclear energy way back in 1940s, when the Second World War the event happened, and that remained in the minds of the people, and they were always feared about the nuclear power production or anything to talk about the nuclear radiations. But as you know, the fact is all these nuclear facilities involving reactors, fuel cycle facilities are designed with highest safety norms starting from the siting stage, construction, operations, and then the decommissioning stages, following the defense and depth approach where no hazard can happen to the public. And if you see the history of the nuclear power, the probability of nuclear accidents is very, very remote, of the order of 10 over minus 7 per reactor here. And so, but we know that there is a tiger, and we have kept the tiger inside a cage, and we cannot we should always keep what is called always keep a guard, a vigil. If any kind of untoward accident happens in a nuclear reactor, how to tackle that situation? So, though we have all the defense center approaches, redundant systems are available, and no possibility of an accident takes place, but still we have to be prepared. For that, we have the emergency preparedness program, which is part of our activities of the department. Unfortunately, in the history of nuclear energy, a few incidents like Human Island reactor accident in the USA in 1970s and the Chernobyl disaster in 1983, and then the recent Fukushima 2011. These events highlight the importance of emergency preparedness of any country, and we have to be prepared even for the smallest kind of event. And those reactors are designed highly safe, but sometimes, for example, beyond design reasons, sectionally factors can cause accidents, and that is what is important for nuclear emergency. Next. India has started working on this, how to prepare for the emergency preparedness in case of a large-scale nuclear accident. So, during the chairmanship of the during 2004 and 5, he has formulated different methodologies how to tackle such nuclear accidents involving the India Nuclear Department, Department of Space, BRC, IGPAR, Atomic Regulatory Board, and various organizations. So, as part of that, an online nuclear emergency response system was developed, and this GS-based response system developed in collaboration with the NRC National Emergency Center, and this basic version was developed in 2005, and recently we have upgraded this decision support system in a common framework for all the nuclear power plant sites by including certain more sophisticated features like all the spatial data of each of the nuclear power plant sites, remote sensing data, and infrastructural data, and a completely spatial analysis system has been made so that emergency managers have all the key information required at the time of emergency, who can simulate and foresee the impact areas and take the countermeasure actions in public domain. And this has the basic capability to simulate, predict the radiation dose, and also suggest suitable protective actions, guidance to the emergency managers. And this follows the Atomic Energy Regulatory Board guidelines. So this is the basic framework. It consists of the sensor network and like the radiation monitors around the nuclear power plant sites. It also has the source term, that means the release rate estimation model. Given the accident event, you can detect the events and it does the calculations of atmospheric dispersion using numerical weather prediction and dispersion force, and it integrates all the data with the GIS framework to make the impact analysis situation. Next. An example is shown here. You see the Kalpata nuclear complex where we have a large number of nuclear facilities like pressurized heavy water reactors, fast food reactors, test reactors, and then fuel cycle facilities like reprocessing plants. We also have a propeller reactor project which is used for the submarines, nuclear submarines, and also waste management facilities. All together, it is a very big complex. So emergency response is very important here. So this, what I show here is the radiation monitoring network consisting of 27 monitors in roughly around 2 rings. And we also we also have isotope monitors in case of an accident. You know what kind of radionuclide got released into the environment. So this consists of the high purity germanium detectors, sodium detectors, and then we also have the eclipse detectors. So all these are used routinely. That means even there is no accident also, they sample the air and measure the radionuclides in the air and gives the information of the activity present in the air. Yes.
So coming to the models, that's what I'm going to tell today. We have two ranges of dispersion, radioactivity dispersion calculations. Yeah, the impact during the nuclear accident is because of the nuclear radiations which are emitted from a reactor in case of any accident. So the release can happen either at the ground level through a reactor containment building or through a stack of a reactor or at a high elevation in the case of the explosion. So it varies time to time. It not depends upon the type of accident. So to make an impact assessment, we need to have a special model, and we also have to have the dynamical meteorological conditions in time. So that's where we have implemented one numerical weather prediction model, which is currently earlier we have used the MN5 model. Now we have gone to the advanced model weather research and forecasting. Yes, and this gives us forecast up to 100 kilometers range around the nuclear power plant site. And in a local scale, up to 20 kilometers, we use a short range dispersion model using the site specific measured meteorological parameters. And this also has a capability to back calculate the source using the radiation sensor data around the nuclear reactor. So the changes that have been done is the MM5 model was updated with the more sophisticated weather research and forecast, advanced research weather forecast model during 2012 onwards. And then we have made the changes of the weather prediction model from 1862 kilometers to 983 kilometers because it has to cover all the nuclear power plant sites of the country. And in this effort, we had to demonstrate whether a coarse resolution model, whether the 3 kilometers high resolution domain can simulate the synoptic scale events as well as topographic circulations around each of the NPT sites. So that was the challenge. Next. So this numerical weather prediction model mainly gets the analysis and the forecast boundary conditions from a global forecast model being run at a National Center for Medium Range Weather Forecasting, NCMR New Delhi. And this data is operationally provided by the NCMR. They will be generating the numerical weather predictions for the medium range up to 15 days. And we make use of the data only up to maximum 4 days. In addition to that, we also make use of the observations in the which are globally communicated using the GPS telecommunication network. And this consists of a large number of observations like surface observations, upper air observations, aircraft observations, buoy observations, and atmospheric motion vectors from the satellite microwave scatometers. And we also have the radiance observations from the satellite radiance sensors. So all these observations are part of this free buffer, and that is used for assimilation using three-dimensional variation data assimilation technique in the weather prediction model. Next. And once these predictions are made up to 96 hours, that numerical weather prediction data, mainly the winds, precipitation, surface fluxes, cloud fractions, and many other parameters are used by the dispersion model to calculate the radioactivity transport and deposition, and that becomes input for the dose calculations for the dose impact calculation for the NPT site. During an accident, the human populations may receive radiation dose through various pathways like the inhalation dose or the direct exposure to the radioactive cloud or through ingestion of radionuclides or through exposure to the contaminated ground surfaces. So all these doses are calculated after the dispersion calculations. Next. And more importantly, we need to know the impact spatially. That means which village is impacted or which area has received more radiation dose. So the database has been integrated in a geographical information system framework to spatially analyze the impact. And this database has been generated for all the nuclear power plant sites. So this system right now can predict the radiation plume dynamically according to the weather conditions prevailing on any given day of accident. and then give the radiation doses to for a corresponding to the accident source. Next. And we need to precisely tell, suppose in case of a severe accident like Fukushima accident, so which villages or which areas have to be immediately taken preventive or protective actions even before the release takes place. So this has to be done by calculating the whole body effective dose, by calculating the whole body effective dose at each grid point in the domain, and then assess the impact whether it is below the tolerable limit or above a certain threshold according to the guidelines, regulatory guidelines, and accordingly the evacuation or prophylaxis or any kind of safety actions can be implemented to the field. So all these calculations are integrated into this relational support system. But the challenge was any model we use, it has a lot of uncertainties, and the uncertainties are more in the case of models because of the non-linearity present in the atmospheric systems. So on one time we may be severely affected by extreme events. On the other case, we may be affected by very calm conditions where the very feeble synaptic force is present. So we need to really configure the model or validate the models for these specific conditions. So we have taken a set of severe cyclones, 10 severe tropical cyclones, and studied the impact of the earlier 6 kilometers resolution domain to the present 3 kilometers resolution domain, whether any sufficient accuracy or benefit is present. Next. And these are various types of cyclones, like for example, severe cyclones, there is with short duration of investigation. Very severe cyclones have moderate investigation, and extremely severe cyclones have long period of investigation and rapid intensification cyclones. So these categories we have taken. Next. And so surprisingly, in all models we use a parameter convection because the clouds cannot be explicitly simulated in the models when the grid resolution is 5 kilometers and above. Because the cloud scale is only a few meters to few maximum 2 kilometers or 2 kilometers. So the model itself cannot resolve the cloud. So we have to explicitly use, we have to actually use a, we have to parameterize the effect of the clouds on the large scale environment. That is what we done in the convective parameterization. But when you use a model at a very high resolution, say a few kilometers, 2 or 3 kilometers, the model is being a non-hydraulic model, it should evolve the convection. And there is no requirement of a parameterized convection. So we have switched off the parameterized convection and only use the non-hydraulic dynamics along with the microphysics in the simulations. So surprisingly, we got very good interesting results that these 3 kilometers resolution simulations far superior compared to the earlier 9 kilometers code simulation, domain simulations, because there is a lot of excessive heating which is generated in case of the birds simulations using parameter convection where the thermal anomaly was very large, and which is ultimately giving very intensive predictions. That means the cyclones are over intensification predicted, and also there is a good improvement in the track predictions because now the vorticity of the system of the cyclones could also be resolved, and there is the steering force which is responsible for the movement of the cyclone is controlled by the cyclone scale simulation as well as the large scale environment. So the ground scale, the cyclone scale simulation, that means the motions within the cyclone could be resolved more accurately in case of 3 kilometers. And finally, the interaction of the cyclone with the large scale environment could be better represented in these 3 kilometers simulations. So that has led to improvement in the track predictions. Next. And the impact is more, that means the improvement is more in case of intensity parameters like maximum suppressed winds and serial pressure simulations. In case of 9 kilometers course simulations, we find there is more intensification in the developing stages itself. So that could be curtailed using the 3 kilometer simulation. In case of a very severe cyclone, the 3 kilometer simulation is not under predicting. It is giving a reasonable prediction or even more interpretation compared to. And these improvements are because the low level convergence and the vertical velocities treated better with the 3 kilometer simulations. And we can see the latent heating, which is generated because of the enhanced latent heating. Good, sir. Go to the next one. So this is and these simulations are however subject to the cloud microphysics that is involved that is used in the model. So we have done a large number of sensitivity studies for various cloud microphysics parameterizations, but we found that the schemes which we use, which generate more snow, water, and these schemes like Armstrong aware and Goddard, these schemes will better simulate the convective systems more compared to the other schemes. And we also compared with the MSC radar data for the vertical velocities. We got very close agreement with the next. Sensitivity studies have been done for extreme rainfall events, Chennai heavy rainfall event. One day, 145 centimeters of rainfall were received, and most of the models failed. On one hand, because the resolution is important, second thing is the cloud microphysics is important. So here we have demonstrated that these schemes, that is the cloud, Thomson and erosion aware and Goddard schemes, these would simulate well the observed rainfall patterns. Next. Similarly, for the Kerala heavy rainfall also we found that these schemes work very well because monsoon systems have not very deep convective systems, and they are rather the convection limited to 6 to 7 kilometers, where these schemes are working good. Next. Next. And then we have also studied the impact of observations. Though there are large number of observations, but the streak of data, which consists of the atmospheric motion vectors, is giving very good impact on the simulations. Though the global model also uses the same data, but there is a lot of thinning done in the GFS. So we need to additionally estimate these observations when you go for regional forecasting. That's what we have implemented at the IDCAR. And this was also studied for a large number of cyclone events. Next, please. And most importantly, for the dispersion predictions, the bound layer is very important. So, how the mixed layer above the ground, a few kilometers above the ground, how it is simulated in the models. There is a large number of uncertainties present. There are a large number of what is called the turbulence roller schemes are developed by the Reynolds average and Navier-Stokes equations. But we found that of all the parameterizations, those schemes which are higher order schemes, including which explicitly simulate the turbulence kinetic energy by solving the turbulence kinetic energy and relate the exchange turbulent exchange coefficients with the TKE, they are doing very good results. And this is what we have done with the experimental data, which was available at IGCAR Kalpakam. A large number of experiments were conducted using the turbulence flow sensors, and then comparing the fluxes and the thermodynamic profiles. Next, please. Next, please. Similarly, we found these simulations for the heavy rainfall events also improved when these Miller-Yamada, Nakanishi, higher order turbulence TK closure scheme is used, mainly because the mixing of the over mixing of the humidity and temperature between the lower regions will lead to drying of the atmosphere, which will not allow the sufficient moisture to get transported to the upper levels, and which will limit the convection, and that's why the models could not pick up the moist convection during even synoptically posted systems. So this Miller-Yamada Nakanishi scheme is able to give us better predictions because it could simulate the mixing property. Next. And this we have validated for number of topographic circulations like land and sea circulation at Kalpakam. Next. Of course, this is another physics study with the land surface models because now we have a large number of land surface which gives the feedback to the bound layer, And unless the soil, what we call the surface energy balance is properly simulated in the model, the feedback doesn't go to the boundary area. And unless the feedback is proper, the units cannot be simulated properly, AC cannot be simulated properly. So all these are interdependent. Now the sophisticated modeling is that the soil hydrology has to be detailed calculations have been done using the canopy effects, ice effects, and any other surface features. So that is what is done in the multi-physics model that is incorporated in the WRF. Next. Next. And over the tiger side, we have very complex separations. Here, blocking effect is there. Mountains will block the flow, and we have very low fever winds which will trap these radioactive releases. So we found that these blocking effects require additional drag effect of the mountains. That's what we have done with the drag parameterization, and it includes the simulations. Next. And this is the topographic circulation at Taraku. And at several NPP sites, we compared with the actual measured observations, both surface as well as array. And we found very good results with these configurations. Next. So with this, we are able to simulate more realistically any kind of the dispersion of the radionuclides in the atmosphere at all the nuclear power plant sites. Next, please. And these are the recent cyclones which are simulated, like the forecast. You can see on the right side, you can see the AMD. Next. This is for the recent mountain cyclone. Next. And incidentally, because we need to validate for a real accident, Fukushima accident we have simulated. We know that the Fukushima accident happened because of the station blackout event, where the power was not available for the cooling of the reactor, then on-site power failed. So at that time, the diesel generators which were available on the back side of the reactor were submerged by the tsunami wave, and all the power failed, and the reactor core, the temperature increased, and therefore explosion has taken place, and the core will completely explode to the environment. Next. And we have made a large number of simulations to validate, to study this dispersion. And the flow was more or less to the Pacific Ocean on all the days, except a few days, a few low pressure systems passed via Japan. That time, the flow was taken back to the land side. And that is the rainfall which happened during the event. You can see the cluster of trajectories, a large number of trajectories are onto the Pacific Ocean, but only few days the plume has moved to the landscape. And these spikes of release happened coincided with the explosions of the steam water explosions and the hydrogen explosions within the reactor, and that has led to the release of a large amount of cesium, styrons, and other things. If you study the deposition patterns, most of the deposition has taken place only by the wet scavenging, wet deposition, not by the dry deposition. And that has led to a lot of contamination underground. So this is actual comparison. On the right side, you see the deposition data. On the left side, you see the simulation. There is a good agreement between the two factors, and that difference is because of the release rate itself. Next. World Health Organization and many organizations have studied this Fukushima accident, and we wanted to know what is the uncertainty in the model predictions. So we have studied the deposition parameterization, mainly the in-cloud scavenging and below-cloud scavenging of the radar plates. So these we found that the parameterization, which is already available in the FlexPath Lagrangian particle dispersion model, gives us more realistic deposition pattern during this event. Next, please. The models have been validated by conducting tracer experiments, erosion dispersion experiments, compared with the dose state monitor data around the site. And these are the projections during various emergency exercises conducted at NPT sites. Next. Tiger site. Recently, the factories and boilers government of Kerala, they have a lot of industries around the Ernakulam district, like the chemical factories, ammonia factories, refineries, they wanted to have a similar system like this nuclear emergency response system. So now we have developed one chemical emergency response system. Like this can simulate like any kind of bhopal gas accident to protect for the emergency management. Next. Yeah. AGSEEN has a atmospheric science program, and as part of it, under the ministry interaction between Department of Space and DAE, we have established one C-band polarimetric doppler radar, which has a range up to 450 kilometers, and this is a unique radar compared to the other conventional radars. Gives us a solid for the power supply systems are very compact. And this has a polarimetric radar in the sense that it can measure the cloud microphysical particles properties more accurately compared to single polarized systems. And it uses additional parameters from what a conventional radar provides. So this will be highly useful for cloud microphysics studies, apart from emergency disaster management purposes. Next is we have also established one microphosphoric wind propeller, a 205 megahertz wind propeller. This helps us to study the winds, gravity waves, turbulence, pixel height information, and many other boundary properties and dynamics of weather systems at the tropical station. Next. So these are our future way forward to study the cloud microphysical studies in the tropical Indian region, and to go for family to data assimilation using the GWR weather observations and wind propeller observations. And also to be able to implement cloud resolving models by using these radar observations, so that we can more accurately predict these tropical chemical systems. Next is to go for greenfield studies, and also use the large. Now the state of art is to go for large area simulations, because our atmospheric conventional weather models, they are not able to simulate some of phenomena because the physics is not sufficient. So the large area simulation models are more advanced, and we would like to implement or even study with boundary flows using large area simulation models. And use these observations for designing, broadcasting, diagnostic systems for early warning for both emergency response and disaster management. Okay. Thank you all for kind patience.
What are the questions? Students? Thank you, Dr. Srivas, for a very nice presentation.
Thank you, sir. Yes, sir. I request Professor D. Bhaskara, sir, please come onto the dais and speak the guest. Thank you, sir.
Good morning, one and all. And firstly, I thank the organizers, and special thanks to C.V. Naidu sir for giving me the opportunity to share with the chair R.R. Rose. And the second speaker, Dr. Professor Chakravarti Vishnuborla. And I would like to read his biodata, and it's a great opportunity for me also to read about the plenary talk speaker. The Professor Chakravarti, he has done MSc Tech Geophysics from Andhra University in 1992, PhD Geophysics from Usmania University in 2006. and is a geophysicist and senior scientist in CSR NGRI from 1998 to 2011. Associate professor from University of Hyderabad from 2011 to 2018. Professor University of Hyderabad from 2018 to the current. The field of specialization of Professor Chakravarti sir is the exploration of geophysics, mathematical modeling, and inversions. The research interest, the areas includes development of new and novel interpretation strategies coupled with relevant software for automatic modeling and inversion of geophysical anomalies. Geophysical field surveys for the exploration of natural resources, including groundwater aquifer at different scales, high-resolution shallow subsurface imaging. And to his contributions, he has received many awards, especially the recipient of CSR Young Scientist Award in 2002, Gold Medal for Indian Geophysical Union in 2005, National Mineral Award in 2007. And he is also serving as an editorial board member, the Associate Editor of Arabian Journal of Geophysics, Springer Nature, and Editorial Board, Journal of Geophysical, in association with Exploration of Geophysics. And he has the outstanding publications, and selectively like the 5 publications is showing that the cross-sectional exponential mass density contrast. And also Professor Chakravarti has published the book chapter, the Encyclopedia of Solid Geophysics. And also he published the a spatial domain model simulations by multiple polygonal cross-section coupled with the exponential density contrast, and also published a long-term land use land cover changes in Eastern Ghats in India. Also he has published basement depths estimation from gravity anomalies, 2.5D approaches coupled with exponential density contrast model. And sir, I would like to invite you for your the fantastic talk. Thank you, sir.
Thank you. Respected Chair, Co-Chair, and distinguished gathering. Good morning to all of you. First of all, I would like to thank the organizers for inviting me here and making me a part of the Platinum Jubilee celebrations of this great department. I don't think I will get a better opportunity than this to express my deep sense of gratitude and respect to all my teachers who made me a better human being in the society and paved me a way to reach a respectable position in the society. Now, coming to the presentation, the title of my talk is Surface of Imaging for Hydrocarbon Exploration upon a non-seismic integrated geophysical approach. So, I'm going to demonstrate how non-seismic geophysical methods play a vital role in the exploration of hydrocarbons, particularly when the data sets are integrated. Now, if you see the overall scenario of India, the production versus the consumption of hydrocarbons, the production of hydrocarbons is 36.1 million tons, and the consumption is about 135 million tons. Whereas the natural gas is about 30.6 BCM versus 41.4 BCM. Now, if you see the projections, the demand for oil increases from 129 million tons oil equivalent in 2005, shortly rises to the 328 in 2030. Whereas in case of the natural gas, you can expect a 3-4 increase in the range from about 29 to 90. Now, to bridge the gap between the production and consumption, there is a need exists to explore new frontier areas for the exploration of hydrocarbons. We all know this is the cemented map of India. There are about 26 cemented basins covering the total basin area of 50.4 million square kilometers. out of which 1.7 million square kilometers on land and about 0.4 million square kilometers in the offshore region up to 1,000 meter depth. Total area explored is 50%, and still 50% of area is to be explored. Now, much of the west central India is covered by flood basalts. This region is known as the Deccan Snake Lines, which also covers to varying degrees the Kalagi and Bhima basins in the southern fringe. The northward deepening of the sedimentary rocks at the fringe clearly indicates that these sedimentary rocks are likely to be present even below the Deccan Snake Lines. This area is still at the knowledge building stage, and the systematic scientific inputs are required to decipher the stratigraphy and the structural style to contain this hydrocarbon planting. This region, as identified by our own people as category 4 basin, which says that it is potentially prospective for the hydrocarbons. Now, the discovery of commercial oil and gas fields in the fermented sediments of the Godavari Basin, and the fact that the source rock studies also show the presence of hydrocarbons in the northern block of Godavari cracking in the Sirancha Gowar. And the Godavari Basin is likely to extend across the Deccan Snake Lines through the addition of many oil companies to explore and ascertain hydrocarbon potential of this region as well. This is because the thermodynamic sediments are also exposed to the surface in this area. So what we have done is that, so on a Pareto scale, we have taken an area covering about 600 square kilometers. This is what is called the Jubilee basin. So here what we have done is we have deployed the integrated geophysics survey to decipher the subsurface structure. So as you can see, the entire area is covered by flood basalts, and these are the patches what I am referring to. So the strike of these sedimentary rocks typically indicates that these rocks are likely to settle even below the impact of the Jubilee basin. So between the Pator and Pandali, these basalts are of secular in nature. Especially area is covered by very massive basalts. And the intertrapping beds are also seen here, south of Pandali, and in and around the Jatapur area, 10 to 12 kilometers, the flat beds are seen as cap rocks over the basalts. Now, if you see what is the problem with the conversion to P wave seismic survey. So P wave seismic survey is forward to setting in geologic study because high reflectivity exists at the top of the vessels, which severely impedes. And such an integrated strategy has proven cost effective in basalt cover. So what is our objectives? Our objective is to model a 3D configuration of the basements of the sediments concealed below the basalt cover and to study its hydrocarbon process. So this is our conceptual model. So this is a three-tiered setup is there, and the sediments you can see are concealed below the thick basalt cover. And if I want to model the basin using gravity data, I need to calculate the gravity effect of the mass deficiency between the basalt and sediments, and should be removed from the Bulgarian anomaly along with the regional field, and then the rest of the picture can be safely modeled to get the basement structure of the concept sediments. So this is what the concept model says. Now, while doing to calculate the gravity effect of the mass deficit between basalt and sediments, it is tantamount to replace the top basalt cover with a fictitious layer whose density is very akin to the concealed sediments. So that is the underlying principle. So in order to calculate the gravity effect, I must know the thickness of the basalt, so which cannot be determined directly either from gravity and magnets, as simple as that. So for that, what we have done is that we have estimated the thickness of the basalt cover using deep resistivity sounding measurements. So as I said, see that, and finally it merges with the Varda river. And based on the structural configuration, we have distinguished the basin into three blocks: the southern, central, and northern block. And in total, we have carried out around 80 deep resistivity sounding measurements with very large dipole lines of order of Jubilee. Now, some of the typical sounding curves I have shown here. Now, if you see the BS, this is 27, yeah. So the rise in the resistivity curve in the initial elevated separation is attributed to the compact basalt, and the drop here is due to the vesicular nature of the basalt, and you have another massive basalt here. Because of that, again the resistivity should be high. But at very large dipole lengths, you can expect a sharp drop in the resistivity that is invariably due to the presence of high conductive zones. In this case, these things are nothing but the concealed segments. And if you see the BS13 in the southern block and as well as BS56 in the northern block, so this kind of nature is not repeated here as such. That itself indicates that the thickness of the basalt attains its maximum both in the northern and southern parts when compared to the central region. And then we have interpreted the data using a transitional layered model against the conventional interpretation using the Jody's method. We have developed our own code, and the data has been interpreted. After that, we have built a borehole here, which has encountered the concealed segments at a depth of 120 to the lab, and we have measured the resistivity. And those resistivities are used as constraints in our interpretation model to estimate the depth values. So using all the thickness of the vessels, and then finally we have prepared isopac of the region. So the picture is quite clear. So the thickness of the vessel is more than 0.3 kilometers in the northern and the southern parts. And whereas at the center, the thickness attains its minimum, about 100. A sharp gradient here is due to the fault along which the Jam River apparently flows from south to north. And beyond this, the Jam River exactly flows towards this basin and finally reaches the water. And then the gravity effect of the basalt cover has been computed, and it's plotted here. So very similar to this, the gravity effect of the mass deficiency between the basalt and the sediments is in excess of 8 milligauss in the north and south, whereas it is about 2 milligauss in the center. This is the observed Bouguer gravity anomaly map of the study region. Though we all know that the gravity data is very sensitive to near surface high density basalt, a large gravity lobe of medium wavelength suggests that the thickness of the concealed sediments is of some significance. Over and above, there are two faults, one across the basin. The Kondari fault is exactly matching this gradient. The other fault, which is the Cotton fault, is exactly following this. This is the 83 milli contours. This is a dislocation in the contours. So we all know that the dislocation of a contours can be safely attributed to the presence of a fault. And a systematic nursing, you can see here, that is due to a deep-seated fault. So the fault system is quite complex in the region. So special attention is required to analyze the data. Now we have removed the gravity effect of the basalt as well as the regional field from the Bouguer gravity anomaly. So what we got is this residual. Now, if you compare this residual with the observed Bouguer gravity anomaly, the following references can be easily made. The circular gravity low becomes elliptical with the major axis trending northeast southwest. It's almost coinciding with the hourly trend. And the circular lows becomes elliptical here within the broad circular low. And the sharpness of the nursing becomes north here. And one more nursing is developed here, which is obscured here in the version of the region. So the gravity data has been interpreted using my own technique. I'm very fortunate to become the first person from CSR in GRI to get an US patent, where I worked previously before joining in the University of Hyderabad. So this is the equation to compute the gravity effect of any prismatic structure. And then the difference between the observed and the calculated anomaly at any node can be explained as a truncated Taylor series expansion. And finally, we have constructed the normal equations, and the normal equations have been solved for the improvements in the depth estimates, and it becomes an iterative process. Now, during this process, what happened? So, up to 10th iteration, my misfit of the L2 norm decreases drastically with the iteration, but after that, it has shown an upward trend. So, there are only two ways to solve that. Either to switch over to the classical macroidal algorithm, which the department is known for that. So if I switch over to the classical macroidal algorithm, there is a possibility that I may land up in a local minima. So to avoid to reach to the local minima, I have minimized the technical function. I'm not going to the details of this. So what I mean to say, my bottom line is that I have used the technical function to reach to a global minimum solution instead of landing into a local. So this is the observed residual, and this is the model residual of the interpretation. So you can see a close fit, so it is not 100% fit, but a close fit between the observed and model anomaly. A few exceptions are definitely there here and everything, but I'm very much satisfied with the kind of interpretation what I have made. Now this is the plan view of the basement structure, and this is a three-dimensional view of the basement structure. One can clearly see that the basement is deepening by and large from south to north. And the faults, what I'm referring to earlier, the Kondal and Kotal faults, where the Kondal fault is here, the Kotal fault is here. And if you represent the figure in a three-dimensional way, you can clearly see there are two basement ridges which almost run east-west direction, divide the basement into three independent depressions. So one ridge is this, and this is one more ridge. And the cutter fault exactly on the southern fringe of the basement ridge here in the middle portion. Of late, we have drilled one more borehole, which we named it as the PKG, which exactly falls on the fault. And this borewell has met with the artesian conditions. So getting artesian conditions in the basalt cover region is a rare phenomenon. Everybody knows that. In this case, what is happening? The basement is deepening towards the north, and the basement ridge acts as a barrier and the cutoff fault acts as a conduit for the upward migration of the water. Even till today, this borewell is yielding water free of energy. And then along this particular profile, AA dash, India has carried out reasonable magnitude television studies. My friend is here, Professor Rannaran is here, and under the guidance of Dr. So India has carried out the reasonable magnitude television studies here, and they also have estimated the basement structure using the MT data. So what I did, I have plotted the cross section that was obtained from the microtellurics and the interpretation carried out from my analysis. So the red one is the basement structure. It's the expansive segments over which I also have plotted the basalt cover. By and large, the basement structure derived by MT and my model coincides in a better way, but a few exceptions exist. For example, the basement structure estimated by MT is showing less dimension when compared to my model, and the basement in case of MT is showing upward, whereas it is not repeated in my model. In this particular case, my model is more appropriate in the sense that the wavelength of the gravity anomaly over the ridge is showing significant wavelength, point number one. And point number two, the gravity load is not confined only up to the basin. It is still extending further northwards beyond the basin boundary. That means the thickness of the sediments must be more and continuing towards the north as well. Now, what the model is conveying to me that subsequent to the deposition of the sediments and the basement might have uplifted along the pre-existing Katon and Kandali faults because the base of the basalt, the convex nature of the basalt over the basement ridges is a testimony to such an amplification. Okay, so that's what about the interpretation says. Now what I did, these are the source parameters. I have collected the values from one of my friends who is working in ONGC from three sites. One is Mandapeta, Ashurapet wells from the borewell data, and then this is the serial checkmark. So the parameters TOC, declared reflectance, and Pmax are showing an increasing trend from Ashurapet well toward the serial check. That means from here to here. That means it also sheds some light about the hydrocarbon potential of the Jam River basin in the northern part as well. In conclusion, so an integrated geophysical modeling using deep resistivity supported by drilling, gravity and empty data to decipher the basement configuration of subterranean sediments is suggested. The gravity effect of the mass deficit between the Cretaceous and the Permian formations was computed and then subtracted from the Bouguer anomaly along with the reasonable field. A 3D inversion of the modified residual gravity resulted in a maximum depth of the basement in excess of 3.4 km. In the central and the northern parts, the faults which are mapped based on the geological studies are well reflected in geophysical interpretation model as well. So because the Godavari basin extends further northwest into the Cassini Plains, and also because the source rock studies of the signature blocks indicate good source of potential for generating hydrocarbons, the study would effectively find application in exploring the hydrocarbons in the JRB as well. So the bottom line is all the data sets were quantified using self-indigenously developed algorithms and software. Thank you very much.
Thank you, sir. Anyone?
Yes, sir.
Interesting paper.
Thank you.
Is there any reason why you did not use magnitudes? Because you use the empty thickness of the substance. You are interested in the thickness of the substance too, right? Gravity is okay. Which one side? The contrast is very less. It can be below the surrounding. Whereas the magnetic can be used.
Spare mic to say. Mic is spare.
How I get it? Is okay, but it's part of just using gravity. I'm getting it. Anybody?
So there are two points to this points. Point number one. Why on the surface we have the basalt, which are very heterogeneous, and everybody knows that once you carry out the magnetic surface over a basalt, the annual picture is so noisy. So perhaps that is one of the reasons why I didn't opt for the magnetics in this particular case. Coming to our point number two, the density contrast between the sediments and the basement. You are right. There is a close affinity between the sedimentary rocks and the sedimentary rocks available in the Chitrakoti subbasin as well. So we have a deep borehole drilled by ONGC in Damabeta, from where we have the density depth log available. So while deciphering the subsurface structure, I never used the constant density model in my interpretation. So the density which was derived using the measured density log from the borehole has been fitted with a density function, and that density function has been incorporated in the model. Thank you. Yeah.
Just
I also have worked in loading area and so on as well. Where I was involved in very large components of the order of country.
There's a big gravity high. Gravity shows multiple ingredients, so that the gravity
No, you can infer a lot of things. If you are getting the it can't be very
Any more questions?
Yes, sir.
using the technology what we have got. We are not and the main and here right order can be
Yes, yes. Before we repeat the question and then no. So what Ravi is saying about finding the basalt is becomes a
base of basalt.
base of basalt becomes a difficult task. The basic thing is that once we adopt any geophysical technique, we have to see the physical property contrast. Which physical property contrast will give me a meaningful signal. Right. So in case of basalts and the sediments, no other geophysical method will give proper signal except ratio. That's it. It's as simple as that. So use large micro length and microscope. Is the same exercise we have done in solar. The same exercise we have done in Gujarat. The same exercise we have done in most of the across the country. I am very fortunate to associate with the great India. The India is given an opportunity to involve in many fields, in wide range of talents. So these are my observations. So
Like say Thailand.
yeah.
Team size. Yes.
Yes.
Right from outside.
Yes. No, the basic thing is that in olden days, when you see the NBR class of including people used to draw the section using the seismics, and then used to draw the gravity anomaly of that without referring to what exactly is the anomaly. Right, it should not like a partner. Once you plot an anomaly, try to interpret. Otherwise, why you should plot the anomaly? Thank you.
Thank you so much. It's a wonderful interaction. Let's break for tea.
Before going to tea, sir, I request Professor K.V. Satyanarayan, sir. I request Professor K.V. Satyanarayan, sir, please come onto the dais to felicitate the Professor Chakravarti, sir.
He is my teacher, who taught me also in this department. I am
So now we have a tea break, 10 minutes. After 10 minutes, again we will assemble here.
As part of these plenary talks, there are two more talks after the tea break. I request you to kindly join back after 10 minutes. Kindly join after 10 minutes after the tea break. There are two more plenary talks after the tea break. I request you to kindly join back.
I can use my laptop here. Separate laptop also. Huh?
లైవ్ స్ట్రీమింగ్ ఉంది కదా సార్, అందుకనే సార్
సార్ శ్రీనివాస్ గారు వెళ్ళారు.
సార్ అన్నారు సార్ ల్యాప్టాప్
పెట్టుకోవచ్చా నా ల్యాప్టాప్?
లైవ్ స్ట్రీమింగ్
నాకు అవనియండి, దానికి అలాగే అవనియండి. నీకు ఇందులోనే కదా వెళ్తుంది లైవ్.
అవును సార్.
ఇప్పుడు ఏంటిది కదా
సార్
దాని తర్వాత
సార్
మరి ఇది బాగాలేదు చెప్తే నేను మార్చే సార్.
ఇది అన్ని పనిచేస్తుంది, పనిచేస్తుంది, ఇది పనిచేస్తుంది. ఎందుకు
హలో
ఇది పనిచేస్తుంది.
ఎస్ సార్ ఎగ్జాక్ట్ పనిచేస్తుంది. హలో ఓకే సార్ వస్తుందా? ఎస్ సార్.
భరత్ సతీష్ వై సతీష్
వచ్చింది మేడం, ఇది కాలం
సతీష్ సతీష్
అలాగే 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 అలాగే
హలో సతీష్
అలాగే సతీష్ ఇలా సతీష్ ఎక్కడ ఉన్నారు?
అంటే మన ఎక్స్పర్ట్ సార్
చూడండి
సెట్ చేస్తారు సార్.
ఇప్పుడు ఇది అయిపోయిన తర్వాత
సార్ మేడం ప్లేనరీ 2 అయిపోయిన తర్వాత అప్పుడు స్టార్ట్ చేస్తాం సార్. ఇంకా 2 ప్లేనరీస్ ఉన్నాయి,
ఇంకా 2 టాప్
ఎలా పెడితే బాగుంటుంది సార్. వీడియో తీసినప్పుడు చాలా సరిపోతుంది.
అవుతుంది కొండ
చేస్తాను సార్, చేస్తాను. ఇప్పుడు ఏసీ రిమోట్ ఆగిపోయింది, అయిపోయింది సార్. మీరు ఏం చేస్తారు తెలుసా, ఇక్కడ ఫోటోషూట్ జరిగేటప్పుడు ఈ లైట్లు ఆన్ చేయండి. ఎవరో ఒకరు స్విచ్ బోర్డ్ దగ్గర కూర్చోండి. ఓకే, అక్కడ కూర్చొని సాయిరామ్
ఇక్కడ నిన్న లోడ్ చేశారండి, నిన్న లోడ్ చేశారు ఎస్టర్డేస్ టాక్. కానీ
ఓకే ఓకే ఇప్పుడు ఇచ్చేయండి సార్. ఇప్పుడు
వాట్సాప్ కానీ ఈమెయిల్ కానీ
ఓన్లీ సార్ యూ కెన్ సార్ నాకు వాట్సాప్ చేయరా? 73 Because
renewable energies needs to be used to reduce the damage we are doing from the climate. And these are the emerging satellites which are going to help us in better product dissemination. ISRO this is not a single nation's worry, it is a global worry. So we are also part of the global initiative on climate monitoring. There is a climate observatory. Yeah, Space for Climate Observatory, ISRO is a signatory. Through that, we are also providing our inputs to global community. So my only request, particularly to end generation, is that we have damaged something, we have to restore that. Kindly keep it in mind. Thank you all.
Questions? And next one, Thank you very much for your informative topic. My question will be those students and users. And this because to know, particularly the satellite, the data, what is the accuracy in horizontal direction? And safety and land rights, particularly coastal regions are back some statement due to the metropolitan line expectations production. And so how the that is there to help our young people and possible implications of physics of geophysical the question is on altimetry data ability as well as for and oxidation. So altimeter data is only useful for the sea ocean area, where we can get centimeter to related accurate information about sea level rise or even undulations also. Whereas for land, it is GNSS data. So there are costs. India has established some of the GNSS receivers at different places, and the data is open. So we can make use of that to understand the changes in the cluster deformation. Particularly, Uttarakhand, there was recently a report that land is. Yesterday also our director has shown that study. So we can make use GNSS. Not altimeter or ocean. That is not possible in use on time because of the problems. Also, all our acts. Also, with company Raga, some post-star, Raga is the post. Also, this, all these, I think, also highlight how our organization.
I agree with you on that anything access is happening, but it is a natural phenomenon and environment. That is how climate changes in its own pace. Our activities, how they are changing in a rapid mode, that we are studying right now. This we have not yet witnessed. I understand. That we have not witnessed.
Winter becomes summer, summer becomes winter.
Yeah.
All these things are driven to the side.
Yeah, the following seasons, in the following seasons also are right.
Any more questions? And let us thank the speakers.
High resolution EM generally comes from data. From satellite point of view or open source initiative. From RODM to Sarcosat EM, you can get from another at 30 meters. Similar way, we will also get a similar product from MISA as well as GAS. 30 meter is freely available. But best kind of 15 centimeter data is also available, but it has some capability is that centimeter level EM is possible. And we already have a couple of data sets for wetlands in the country. Bihar, Assam, or Godavari, we have that. But that is with
Thank you, sir. Now I request Professor Y.V. Subbarao, sir. Can state the
Yes, sir.
Sir, what?
GPS satellites within basically satellites. Again, so is it can work in all the world or only in Asia? We are looking for a
That is actually not a satellite. It is a processing environment where we are processing in real time the GPS data. For a GPS, there are several constellations are there. GPS is from USA, and Russia has its own, China has its own, and European community. ISA has its own. India also has its own for regional purposes. So India and adjoining countries, we have a regional network. India. So that few satellites are already launched, and furthermore needs to be launched to operationally use for normal commercial applications. For defense, it is already in use.
Gravity is only Indian physics, not in the
I think it depends on funding. Okay. So we have, you know that we have limited resources every year, including here. So within that, our first goal is our country. So towards that we are.
Thank you, sir.
Thank you, sir. Thank you so much. Next speaker.
Yeah. A small hill station. Thank you, sir. Thank you, sir.
Mr. P. Ramarao Garu, please come on to the dais and felicitate him, please.
Yeah, I'm sorry, every time same person coming onto the dais may not looking good. But yesterday, we wished to Professor P. Bhaskara Garu and also another Professor Gopal Krishna. He is also our alumni. Both of them detailed histories from Professor I. V. Radhakrishnan. So it is a pleasure for us to honor them with a token of memento and a small song and a token of remembrance of itself. Please accept.
Sir, we have one more. Sir, we have one more guest, sir, who is our alumni. I request Professor Gopal Krishna Garu to come on to the dais, please, please, sir. And he worked as a HOD in Geetham University. He worked there, and I was working under his guidance. I was an assistant professor under his leadership. So I request Professor P. Ramarao to illustrate him. Master.
Yes.
Next speaker, Sri Chetan Anand Garu. And before I invite him, his student, Dr. Srinivas Garu, wanted to read his portfolio. So I request Srinivas Garu to read his Professor. Yeah, sorry. So Professor Srinivas Garu to read his portfolio. Thank you.
I don't think so. I should introduce Chetan Anand. I think all of you know him already. No, a man with the golden heart. Let me tell you, he's Mr. Chetan Anand Curry. He is, he is my classmate, benchmate, and we are classmates since 1992, since degree. So he came forward. The first thing he said is, it is 75 years of Jubilee. So I will say, I will give 75,000. But I asked him, sir, Chetan, can you renovate this hall? So he started renovating this hall and he made it like this. And he spent at least 3.7 lakhs for this hall. He started with little things, but this became so big that he didn't compromise at all. He used to come, he used to come very often and check even the curtains here, because he selected the curtains, he selected the paint, he selected everything. He was very cautious, very sure that we get the best. So he has such a golden heart. I mean, I'm so thankful to be with him, and I'm so thankful that I'm his classmate, his friend, and I thank him. From bottom of my heart, I would like to thank Chetan for his efforts, and I'm sure that God will see you. Thank you, thank you, thank you. And today he is going to, and let me tell you, he is not only a person with golden heart, he is a very good scientist, and he works in SAE exploration. He is a chief geophysicist for South Pacific, and he works on shallow seismics, land. So he has a very wide experience for the last 24 years in the oil industry, and he takes care of billions of dollars projects for his company. And he's such a big shot, and let me tell you, and I'm not exaggerating, and you'll see his presentation. At this moment, we have the privilege that we have him here, and we are so thankful that he has put all his time, efforts to come here, present the latest techniques he's using for oil in the field of oil exploration. Thank you so much for your attention.
Thank you, sir. Okay, good afternoon, respected teachers, respected alumni, my colleagues, and my dear fellow young geophysicists, upcoming geophysicists. Can you put the slides? Project. Okay, first of all, thank you, head of the department, C.V. Naikar, for giving me an opportunity to renovate this. I hope it came good. We just spent a little much, so later, for next 25 years, I hope our students can enjoy this facility, having the seminar. Okay, I want to go through the shallow seismic service. This is a very interesting topic, and I will put all practical examples, what we face in the field, and what we are doing. So I am passed out in 98. I am from 95-98 batch, and after that I worked under Lakshmipati Rajaguru as a research scholar, and I could complete the PhD, and I jumped into the oil and gas field. I started with an Indian company, Shivani, for an OEPC project in Tamil Nadu, and after that, I was observed in a company called Geophysics in 2002. Since then, to till date, the company has changed the names, and now it is under the name of SA Exploration. So I'm looking after the Asia Pacific. I'm a regional geophysicist. The next slide. So here, what I want to discuss is few benefits of OBS, ocean bottom surface. Why it is broadband better? Acquiring low frequency challenges in the different types of sources. Then there is another interesting source which replaces the explosives is impulse source, which is on-site series what we call. And then there is, everybody knows about the vibrators and vibrosers, but we have many vibrators. I want to just go through that many vibrators. Various source types in modern seismics and the receiver and node types, I will go through one by one. Quickly, I hope I will finish in a given time. Next. So, what is OPS? OPS, where we stand is one survey, multiple environments. We start from land, from hilly terrain to the jungle, to the transition zone, shallow water. Shallow water comes up to 50 meters, and then more than 50 meters goes to the deep water. The deep water, what is mentioned is 500 meters. Right now, the nodes which is available in the industry is handles up to 3,000 meter water depth. The recent survey carried out at ONGC in Krishna KG Basin is cluster 3 block. and the water depth was 2,950 meters. They deployed nodes of shear water using the ROVs. That's the deepest. Next. So, going back from the steamer acquisition, normally everybody knows that there is a steamer acquisition into the steamers. So, but in the steamer acquisition, there is a limitation there. Cannot operate efficiently in less than 15 to 20 meters water depth because you have to do the wider steamers. You need to put more air in the water. So that's the limitation of the steamer water. So the steamers are restricted to the 20 meters plus water depth. Limited operations around the infrastructures. Any congested oil fields are there, the steamers cannot go as close to that. So it has to make a big deviations and go. Then you see the quantity over volume. When you compare the steamer is cheaper when compared to OBN service. However, there is a restrictions. We cannot get the azimuthal distributions, limited azimuthal distribution. We will be already able to acquire a limited, like a narrow azimuth service, or maybe a wide azimuth service, but not full azimuth service, which is required at present in the industry. So, like if you want to go wide azimuth survey, medium azimuth survey, and far azimuth survey, which is expensive and operationally very difficult. The noise generated from the steamer, more the spread you put in the water, the noise generated is also a challenge in the processing. Navigation, more the rain you put, more the air controls you need to put in, and its managing is very difficult. So, steamer surveys is in one way it is good, the other way if you go into detail, it has so much challenges. Next. Come back to the benefits of the OPS, ocean bottom surveys. Here, we can go from the water depth from 0 to 3,000 meters, which is checked. Work through all obstructions. Any obstructions as close to the platform, we can go. Recent my practical experience with Mumbai High Field, the complex field for India, the mother of India is the Mumbai High Field. We recently completed both Mumbai High South and Mumbai High North, 2,000 square kilometers, full azimuth, dense OPN survey. The node spacing was 100 meters, and we managed to deploy that node, which I will show you later, as close to the platform at 50 meters from the platform level. But whereas with the steamer, we can go as that close. Then you can get the quality, full azimuth offsets. The cost comparison is we have to compromise. We have to put it in the middle. Minimal noise environment for sanitary sea flows. Absolute positioning and measured depth very accurately we measure. I was listening from yesterday. We talked more about GNS. We use intensive GNS and GPS and different types of sensors to accurately use the positioning system. Direct coupling to the seafloor, the nodes are directly placed in the seafloor. Wider spectrum, full 4 components. In steamer, you can record maximum hydrophone and a geophone. In some steamers, but mostly it's a hydrophone. Whereas in OPS, ocean bottom surveys in OPS, we are allowed to record 4 components. Hydrophone, vertical geophones, inline component, and cross-line components, which is very good and equal, which is required for the shear wave processing and for better illumination or mapping of gas. Tailored equipment, you can tailor air gun and different types of 3D and 4D repeatability services. As I mentioned, OPS surveys instead of steamers, this is the famous Kati field of ONGC, where the water depths are from 0 to 30 meters. The beauty of this place is that it's the sand bars, moving sand bars. You mark on sand bars today, you come back after the weather period, 6 months, that sandbar will be not there, it will be completely moved. However, saying that successfully, we have completed 2,900 square kilometers in this field using a ocean bottom rods. You get improved resolutions, you can go as close to the obstructions and full azimuth for the reservoir bank. You can see this is an example I just pulled out from. This is from the Alba field in the north, UK, close to the Norway. Very famous field. This is the steamer data, and see with the multi-component, you get a better gap is filled with a much more information is achieved. Next. With using the OBS, when compared to the steamer and OBS, you see the noise can be maximum control because the sensors is right place in the sea floor where it is controlled, whereas the steamer is floating in the surface. And the better mapping of the multiples can be done with the OBS surveys. Another, after doing when coming from the OBS, it's not stopped there. It's moved to the broadband. The people didn't stop there. They want to open the broadband. So then why broadband? See that if with the conventional survey, OBS survey, this is the image there. And with the broadband, you see that the depth of the image, all the reflections of the structure is very clearly planned. Why broadband? Is the interpretability, inversion, integration, and full waveform information. You get everything with a better broadband data you acquire. With conventional, you see this is the graph. You see that how the blue one is showing the conventional, whereas in the broadband, you get a flat spectrum. You get many more frequencies which is required, which is useful. In good old days, nobody cared before 10 hertz. But now the interest is all up to 1 hertz. Just remove the swell noise, and the remaining is the interest is over there. Next. So this is an example. If you see this octaves, bandwidth and interpretability. The tighter the bandwidth, you get a sharper image. And that opens up the wider frequencies. Here it is 60 to 32 hertz, but whereas if you go to broadband, it is 256 hertz. Just showing an example in the rock properties, how this can be useful in the different understanding the rock properties with the broadband data. This is all the different types of studies is going on, it's carrying on. Every department, every organizations are doing it. Next. Okay, see, now you see that you need to just keep on by. Next. No. Forward. Yeah. You see, you add one, this is the well-known velocity file, and then you put a 60 to 32 octave. And then when you increase, next. Now you see, keep increasing, you add 2 octaves, 16 to 64. The blue one, you are trying to match with the actual well-known. The more you add the octaves, it's better it gets correlated with the actual field well-known. Yeah, adding high frequencies add resolutions to the inversion, which helps in later in the interpretation and other.
So what is that?
So the blue one is the theoretical. So you add more octaves. The red one is the velocity one. Yeah. Next. Yeah, see this, you add more octaves, adding low frequencies, add accuracies in them. So all this is getting, you add this, from 16 to 32, we go on to 1 to 32. And you see this blue is exactly fit with the field one. So that is what is the importance of the broadband and that is an example showing. Next. Just look at. See that this is a well-known. how here is the example taken from the one of the textbooks, showing that inversion with the low frequency or what is the benefit. With the plot, go back. Go back. Okay. Now, if you add forward. Yes. See, by adding the broadband, you get continuity. Earlier, we didn't get that in good old days. Okay. Next. Okay, acquiring the low frequency is again a challenge. So we take the three examples: viruses, dynamite, and airgun. So viruses. Next. For viruses, the limiting factor is all these are the limiting factors: piston, stroke, hydraulic flow rate, hold on weight, supply. Because in order to get the low longer duration is more expensive. Next. There you go back. Don't click on that. Okay. So this is the load valve screen, and that is a what is generated is 1 to 36, 24-second speed. And now in the dynamite, you can see the low frequency challenges is we need to drill deeper holes, larger charge cells. In the frequency domain, we absorb the well-known shifts of the peak amplitude responsible for the lower frequency, larger than. So you see there by adding more charge, deeper hole is more expensive, and in more hilly areas it is difficult to achieve. So, and getting this low frequency using the dynamite is again a challenge. So we have multiple effects as a low the source goes and multiple things. So the challenge is there in microsize as well as in the low in the dynamite. So there is a concept. It came long back. It's a spatial sampling. So whenever we design a 3D survey, this is a standard formula. The traditional sampling, spatial sampling is high frequencies. Low frequencies are oversampled, and sometimes very low frequencies are not at all required. Whereas in broadband sampling, what happened is, see this one, mid to high frequency, low frequencies, and very low frequency. I'll show you this. Why this is called as a symphony? We came up with this concept in geophysicics. It's a symphony is like a, like a guitar, like an orchestra. If you put a one unit to play, it will give one set of sounds. If you put all one each unit to play, it will generate a single type of sounds. When you combine it, it looks melodious. Like the same way, look next one. The same. You have the different types of. It just compare the why we call this sampling is. We don't need every short and receivers. What we are trying to say is that in order to require the low frequencies, you don't need to drill every 50-meter hole or every 100-meter hole. You need to drill sufficient spacing, which is decided by the target depth electricity. Then you can define and you can pinpoint the accurate plan of holes such that the cost will be reduced. So that is what is the concept of the spatial sampling. So this, if you require the microsite survey, normal microsite survey at 40 to 100 Hz, this is what the structure, the image looks like. Whereas the C, if it is recorded with a broadband, 1.5 to 100 Hz, see that the same events, how better and how clearly defined. Broadband is support better in. This is recorded with 12 second speed. This is recorded with a 36 second speed. What is happening is, if you take, for example, recording full broadband, it takes 19 hours to shoot this particular section. the same, if you use the symmetry model, you can use it half of the time, you get the similar effect. That is the concept of planning and properly wanting your survey design. Now, to add to that symmetry concept, now the many clients are also going to see this side concept, compensated seismic sources. So they're planning the source and source properly planned, not the technology that they're doing. Next. Now come back to the I covered microsize and now the air gun. Air gun is another air gun. It's hard to record the low frequencies until a couple of years back. Telcel has modeled this new source called Q pulse source. It's a low frequency source. This is one single gun. It is only one single gun. The volume of the gun is 28,000 cubic inch. And it fires, you can adjust, depending upon the unit of how much pressure. Recently, we acquired the surveys in Malaysia, 2 surveys. One survey I modeled for 1000 psi. We acquired to match with the airgun data. The other one we acquired with the 500 psi to match with another airgun data of 71. So we can manage, but that generates a low frequency. Next. This is what Telcel's new source GPS is the best in the class in respect of its very low frequency content. It is unique in that it can generate the highest amplitude signal at frequencies of less than 3 Hz, which is very difficult in the normal airgun. So this is very interesting. Telcel is something else. TPS is also more environmental friendly source option in the industry today. You will use high frequency emission. If you have a higher frequency with a normal air gun, you cannot use it where the mammals are there. This is a big restriction. For example, in Brazil, offshore Brazil, you cannot use an air gun anywhere. We are awarded one job last year for Petrobras. Till now, almost 1 year, they are waiting for the environmental impact EIA report. Until and unless we get it, we are not allowed because the areas what we have model, it has to be compliant with all the marine mammals. Now you can see this here. It's a very good example. The low frequencies, which is earlier not acquired with the conventional sources, it is being all captured with this new source. Yeah, next. So this is what the survey which we did is CAG congested. It's a combination with both conventional as well as the DPS. Next. Now come back to the marine vibrator evolution. So this marine vibrator is not like a normal vibrator going down like this, shaking in the ground. It's not like that. It's a piezoelectric membrane where you send the electrical pulse, it converts the electrical energy to the sound waves, and that is how it's generated. It's very eco-friendly. You can tow marine source with the similar energies as close to the airgun, and it's very good in the wherever environmentally sensitive areas. You can use this source, but it is not 100% available. Still, research is going next. So we started with like this option. It has two different types, subtone and micro. And now we are coming up with that model. It's a fully automated, which is in the manufacturing. Next. So this is testing of micro. Next one. Okay. I'll take 5 minutes. On-site, it's an impulsive source. Dynamites are not used everywhere. For example, in the urban areas and everything, we cannot use dynamites. So what is the source? Some of the areas are a lot of gaps are there, data gaps are there. On-sites. On-sites is on-source synchronized electrical impulse source. It is everybody might be knowing the accelerated wave drop. It is advanced to the accelerated wave drop. In accelerated wave drop, you don't have. So this is in the past you have DG plus. These are all accelerated wave drops. Whereas you cannot synchronize the time with the accelerated wave drop. Whereas in on-sites, you have the capability to synchronize every form it takes. When you start it takes, you can synchronize, you can stack it, same like a vector size, and it is equivalent to the, you can get the impulse source same as the time value. It's very good use and it is easily, you can go into the easy to maneuver in the fields, in the urban areas, less footprint, and if you do the PPV surveys to measure how it is less than 5, even though it shoots here, nothing, no damage happens. So that is the accelerated wave drop example. Next. So this is how on-sites work. It's all in the electrical. Yeah, that's the form this generated. So it's different from the free fall and go back. Okay. In the free fall, you just fall. You don't know what time you fall. Yeah, but you cannot synchronize, right? But whereas this one, you can control with on-sites, you can control. You can send a pulse to go and shoot and pop it. And you can pop multiple times and you can stack that. So that is why it is different from that.
It is a number of doses like
Why that?
it comes.
Number of?
Is a wide.
Yeah, you can put it not one, you can put multiple. I'll show you the picture. Okay. Next. You can put it in there. Next. Okay. You see, that is the 60,000 pound vibrator. 18,000 environmental vibrator. And see that size. And where is the on-size, dual on-size? This is the dual on-size, 2 packs. And that is less than the size of the Ford car or Tata Nexus car. Less than the Sriva's car. It is less in the length. So it is so compact. That is why you use this. Next. This is an example. See, all these points have been acquired by the vibrosys, but in this area, where the vibrosys cannot go. But these guys, because it's track mounted, you can send it. This is acquired in the Peru, South America. And like that, to answer your question, yeah. See, this is a stack of 4. 4 on size, 4 times 2, 8. You do multiple pops, you can generate, you can stack all the data, it will give. You can give an example. You see that environmental wise, how the stack looks like and the on size. This is very close resemblance. Next. Okay, I'll go fast here. Marine nodes. In the industry, there are multiple type of nodal nodes are there. This is a geospace, and this one is the platinum case, which is deployed more than 500 feet of water depth. On the top is Ginebra node, and the bottom donut shape is the G700 nodes. They are all the future right now. Next. Okay, by the way, recently we acquired this year this company. So SAE owns Ginebra and we have 5,000 own nodes. They are capable of 3,000 feet of water depth. When you deploy the nodes, okay. This is how the nodes are deployed in the sequence. Next. Actually, I'm missing that. Next. Okay. These are the different, using the node of probe, how the nodes are deployed in the water. We use the tensor probe and connect to the rope. This is how the rope we can configure 50 meter, 100 meter. The rope is flexible. You can drop as close to the infrastructure. Recent examples in all the ONGC fields and in the Western offshore. It's a great experience, great example. And I witnessed from last 3 years I was doing that, and not even a single pipeline. Out of spaghetti of pipelines, I have not touched a single pipeline. In fact, I have informed the asset wherever the leaks are there. Because it's the whole field. I gave 20 plus locations to the MS South, Mr. Babugar, wherever there is there, and he's from Osmania University. Next. This is another new steamer receiver. Next. Okay. Another interesting, this is one more interesting now. Distributed acoustic sensing task. Now this is getting very much interested in the industry. It's a fiber optic cable. What is do with the fiber optic cable in the seismic industry? I was also very new with that, but recently, almost in a year, we did two surveys. One we did in the it's a good replication to the vertical VST programs. In a 3,000 meter hole, the drill there, we deployed this optical cable, and the fiber is connected every 1 meter. The amount of resolution you receive is amazing. And recently, we deployed 26 kilometers of fiber optic line, and then we shoot on top of it the airgun. So this is what the different types of benefits are there: high density sensor, fiber optic technology, diverse applications. It's coming for multiple purposes. The noise levels are less, the quality is very good. Handling is right now is a bit expensive and more challenging. The recording of this equipment is only 2 companies are there, Alexa and 2 companies are there. Very challenging to get the data out, but this is, I can see for the ultra shallow transition zone areas, this is the upcoming. Using the replace with the normal OBC cable. Can it be used for tsunami prediction? So what happened is, like recently we did the survey what we did in Peninsula Malaysia. There was a buried optical fiber cable is there. So the cable is there. It can be there in anywhere. Whatever we need to do is, these are the interrogator units. Where the control unit is there, you need to just connect that interrogator. You can record. You just keep that unit and keep recording. You will get for any type of mark. Because what it does is, go to the next one. Yeah, you see, it sends it's a two-way. The fiber, it sends a signal and then it receives it. And then it is, this is how you can get the like a seismic signal. And the resolution, because it is connected at every 1 meter the fiber, and once the cable is deployed, it's cheap. And you need to just keep recording, and it is very high resolution. Next. Some examples for the kids. I just want to show this, how the different environments where they work in the jungle. You can go to the next. In the Arctic. I started my career with 2 components. 2 components are you might be doing 2 components with air analysis. Then we came to the Circle OBN service, the OBC cable for Circle 428. And after that, now these 2 are history. Nobody is using because the cost of maintaining the equipment and everything is too tremendously high. And compared now, we are all, everybody come back to the nodal systems. All companies are having the nodes. We own Geospace 8,000 nodes, Brazilian 5,000 nodes. Shearwater is having a Pearl, they manufacture their own nodes. So these 2 are very much good in the market. When you go to the Russians, they use crab. The node name is called crab. The sensors, the geophones, what is used in that in OBN nodes, as well as in the crab, is both that is the normal geophone, the same component. So next. We as a company, we can, when we come containerized wire containers, all this comes in a 20 to 30 containers. We unpack it, we assemble it, and then we can put back to the work. And these are very special types of source vessels, ultra shallow, up to 1 meter to 5 meters, we can use them, those vessels. Now the new vessels which we are right now which is starting in April, will be using these vessels. This is fully remote control. Everything is remote control. Only one people will be there and rest will be on the control side. So this is how the technology has changed. Good old, we have the recording system, bunch of observers, party managers and everything. Now we have only one people sitting up there. This automatic vessel, everything is being controlled from the command center sitting here. That's it. So we are tied up with this company, Ocean Infinity, and we are using it. I think it's almost done. Yes. This is some example. Next. Next. Okay, this is the last one. Last slide. Different types of designs. In order to get a better results, you need to have a different design. So this is one of the very simple two-line survey, orthogonal survey, 6-line full orthogonal. Now this is all gone. Now it is double-sided parallel design. This is one. You have a bunch of receivers laying, and the shots are fired on either side. This is done in order to get the full azimuth survey. So we are very much in that double-sided parallel, and with that you can use multiple source vessels, and then if you shoot multiple source vessels at any given times, and there is a beautiful processing techniques where you can for do blending, you can remove and see. So I think that's all with that. This is what I want to present to all. Thank you.
Thank you so much. Since we are running out of time, please.
I got a question.
Yeah, questions.
How do you account for the low frequency signals?
Low frequency seismic signals from
Actually, that will be a noise in this case.
By replacing with the sensors, right? Earlier, the normal geophones is 10 Hz. Now we have the geophones. The receivers are also being changed. Not only the source side, in the receiver side also changed. They have come back to the close to the 5 Hz, less than 5 Hz. And the MEMS also came. MEMS is recording everything. MEMS is not a geophone, it's all accelerometer. From that, in the processing, you need to convert from the acceleration to the velocities, and then we can.
You can eliminate that as well.
Sir. Second question, please.
By deploying this technology, can you mark the behavior of a seed reservoir?
That is what the OPM survey is. Some of you part is the knowledge. What they do is physically pull the nodes which I mentioned in April. In April is having a battery life of 150 days. Normal OPM's geosticks is having a 40, 50, 75, 90 days. But in April is 150 days. You place the node close to the reservoir, and then you come and do the cycle return. And there is another type of sensors are there, which pretty much not what they do is they fetch the feed and they deploy the sensors, they do the survey, and they come back in the period, and they come back and re-acquire the survey. The same can be applied to the task.
Thank you. Last the short questions.
I question is only one. What do you go here? They are doing that. The basic issue is what is cost and they not here. So like in land where Korean they are in the
Land we do three component, right? In OPM we come up to water depth up to 2 meters. We need to have a water or a hydrophone towards. So OPM, the nodes are having a the component of geoforce plus a hydrogen. In order to get a proper result of a hydrogen, you need to have a water of a minimum 2 meters, so that the pressure you can sense. So you can come in the transition. You can put the onshore units on a shepherd boats and then put it on the top, and then you can refer.
Thank you so much. It was such a wonderful talk by Chetanana. I request Dr. G. Srinivas, Team Director, NRSA, to felicitate Chetan. Thank you so much.
So now we have break for lunch. After break, we have two parallel sessions. So actually, yesterday we have two pending lectures. After lunch, the energy theme, two pending lectures will be continued here. And here, lecture hall 1 this is, and lecture hall 2 is first year classroom. Let us send to this hall. So we will move to the lunch.
I just want to urge all the young students.
So I request coaching team for teachers now.
Okay, sir.
Sir, we will break for lunch. Yeah. Yeah. A small request to youngsters.
I have a small request and suggestion, youngsters. Please take contact with these four excellent speakers. Take their advantage of their expertise and resources. Okay.
Chetan is quite clear, actually comes perfect. Thank you so much.
Hello. In this hall, we have environmental geophysics. Students, please guide to the guests.
CV Spencer గారు టాక్ అంటే అక్కడ ఎందుకంటే ఇప్పుడు CV Spencer గారు
available through OSCAT website. So these data sets which I showed require further processing from those data eventually release system.
Okay. Thank you. Any speaker left from yesterday who could not speak here? Sri N. Chandrababu. Any other speaker, if available, please come forward and report to the speaker chair. If not, Mr. Mahesh is there. Mr. Mahesh Pathakoti. Okay, the next invited talk, tectonic history of Eastern Vindhyan Basin through integration of potential data with other geoscientific data. Invited talk by me. Not working. Okay. Ambition, not that. Okay. Can they get A25, 2 to 25. Just put that time zone. Good afternoon. The topic here is the tectonic history of Eastern Vindhyan Basin. As you all know that. Geophysics from wood to metal. We have to remember that we talk about gravity. The person is called the father of gravity and Dr. Professor Mani Salwani. He is the person for the students and others who don't know. I just want to intimate that he is the first person who has worked with gravity magnetic on moon. Coming to my topic, it's a Vindhyan Basin in brief. We have to talk about Vindhyan Basin. It is the protozoic intercontinental basin. It is the largest basin in India, second largest basin in the world. And it has got a huge area, 165,000 plus, and having a 5-kilometer huge sediment thickness. The interest is because it is tectonically less disturbed and a shallow marine sedimentary rock with a huge sedimentary base. And one more thing is the most interesting part for the exploration is that the basin is almost similar to Lena Tunguska Basin in Russia and Amadeus Basin in Australia. When you come to the protozoic basins and we talk about, we have to talk about the major Archean in India. That is the Darwan, Buster Singham and Bundelkhand Craton. And then we'll talk about Precambrian terrain, whatever available there. And then protozoic basins like Alpha Chhattisgarh Vindhyan Basin, along with several smaller basins like Karya, Buster, Bhima, Kalati. And of course, here we are not adding the Malwa Basin, which is coming in the northwestern side of Vindhyan Basin. The Vindhyan Basin is bounded by, as I already written there, the Mughal Shastra Ridge, which will take Vindhyan Basin to the Ganga Basin. And then great boundary forest is in the west-northwest direction, which is dividing this into the Malwa Basin. And then coming to the Bundelkhand Massif in the west-northwest and Indo-Gangetic plains going towards the north. And the Son Narmada lineament is coming in the southern part. which again is the boundary to the CA region. Many people say that many researchers have found that some of the Indian basin sediments have come into the Ganga basin also. There are so many researchers have proved that, but yet, as long as today's scenario is concerned, Indian basin is limited by Bundelkhand National. The lower Indian sequence is dominantly calcareous and argillaceous, and then upper Indian sequence is dominantly argillaceous and argillaceous. There are so many theories which have come up. Each and every theory has worked in some place or the other, so I will call them as piecemeal studies. And then I will try to explain that why that particular previous exploration theory by the previous workers has not been taken into consideration when coming to the crustal theory evaluation of the basin. Peripheral foreland basin by Chakravarti et al. It is not constrained by the years data. When we are comparing to the geochronological information, because it is a proterozoic basin, the chronological information also makes a lot of importance. When it is not matching with the chronological data, that has not been taken into consideration. And coming to basin evaluation by Jokanram et al. As my guru, the pre-script, post-script, and other phases of development have been taken. It's an excellent study by Jokanram sir. The basic thing here is the Jokanram sir whole thing is dependent particularly and limited to the, I can say that, Damo, Javera and Nota areas, which is part of the Son Valley, not completely considering the Son Valley. Coming to the Durgapur reserve forest, nothing has been taken into consideration in the study. So coming to the slide-wise stratigraphy compared to the geological information, what we have is several discrete blocks in that area, which have been taken into consideration for understanding the basin. The formations what we have limestone, sandstone and conglomerate. Basically the low region part volcanics I would like to take it to the I will require your attention to the volcanics because when we talk about the high velocity ranges and different tectonic disturbances, the volcanic elastics also matter a lot. So the major four lineaments in fact geology, but some lineaments have been associated with the faults along with the lineament. So I put the word major fault as lineament. Great boundary fault, of course, everybody knows that. Jalava lineament and Asmara lineament is the one which is running parallel to the Ratnapanna ridge. And then coming to the Son Narmada lineament, that the most major tectonic activities, including the crustal upwarping in the eastern side of the Son Narmada lineament has been taken place, and it is very well known fact. Then coming to the earlier studies, the DSS studies by NJRI, it is so many NJRI friends are there. So this there are three major DSS profiles have gone through the basin. One is Chambal Valley side, that is Khajuria, Kalam, Kulgam. It's coming in the western part of my study area, and in the other side, basically the one profile which is following is the Hirapur Mandla profile, which is straight away falling in the eastern Indian basin, Ritter Son Valley, which has been lead to me to understand major fault patterns have gone into the deeper levels up to crustal level faults. That is more important. The crustal level faults, when you cannot show in the seismics, so the effect of seismological information what I have taken from the DSS has helped me a lot to understand the crustal elevation at the deeper level. This generalized stratigraphy when we talk about, we have the western and eastern Indian basins. Western basin basically covering the Chambal Valley path, which has already been covered by Deccan Trap a lot. So most of the seismic works could not be taken place in the central and southern part of the Chambal basin, whereas some of the basin parts have been taken into the northern part of the central basin. So this is my studies. I am not going into much explanation because gravity magnetic researchers can understand what I have done here. The radial temperature separation and image enhancement techniques have been taken under the gravity and magnetic profile to understand the information which can be taken into the consideration about the fault patterns and the lineament extensions. The interpretation of the seismic reflection data has given me a freedom to constrain the seismic data into the sedimentary levels to understand the behavior of the sedimentary pattern within the major basin. Coming to the joint modeling, when I come along with the gravity magnetic, I could understand that the crustal levels at the from the upper crust, lower crust behaviors, and then seismological information gave me the freedom to talk about and understand the basiness towards the sedimentary part. Based on my studies on seismic and seismological data, along with all functions, but we have got the seismological station within the area. We have taken the crustal velocities and understood that the velocity from basement upper and lower crust have been changing, and then the seismic velocities have been taken by the 2D seismic data, 2D multi-channel seismic data, for which I have taken the permission from ONGC. Then this is one representative. You can see that the way in which the geological section and then the surface geological model and then gravity and magnetics, how they behave. Here I would like to say that as I have already mentioned here that the aeromagnetic data could not be taken in the Chambal Valley because the already crustal level depth flap is covered, the magnetic data is behaving erratically. So at that place, we have taken the EMAG data into consideration to smoothly pass on the aeromagnetic data into the seismic to the area. Then this is one of the representative 2D multi-channel seismic lines. You can see that here the Hiraku Mandla seismic profile is showing the sedimentary levels has been taken into consideration. Yes, sir. Coming back. Then this is the geophysical response along with context. You can see here the what we have done is a 3D gravity inversion has given us an idea about the behavior of the moho, and this moho behavior has shown that the variations in the moho has shown me that the western part of the area, what the study area, has got more tectonic disturbances when compared to the eastern part, where the sedimentation pattern has been smoother. So here, the surface geology, then I am comparing with the gravity and magnetic data, I can see that the Ratnam Panla area has been taken very clearly, which has been, this is the rich area where we have got the pipes and all. So lot of things have been done. Professor N.D. Kalpatra has worked a lot on it. And here we have done the Son Narmada lineament. The Son Narmada lineament has been taken into Son Narmada fault zone, where the Son Narmada north and south fault. Within the Son Narmada north and south fault, there is a big fault zone where the tectonic disturbances have happened. I have already shown that the crustal apportionment has been taken care of, and those signatures have come into my seismic surveys also. That means the crustal level tectonic disturbances have come up from the top to bottom. And here, when you come up with the crustal evaluation model, you can easily see that these are the faults, most of the faults are coming to upper to middle crustal level within that area. That shows that the Son Narmada lineament has come right from the crustal levels. So this here telling that the study has brought out a clear understanding of the tectonic scenario and sedimentary pattern. Regional crustal studies actually have brought out the understanding about the regional tectonic scenario. First one is the local tectonic scenario, and the second one, the regional tectonic scenario, could be understood. And then salient results have brought out with the seismic, we could have several crustal level faults. The velocity studies have revealed us that the crustal structure itself has got 3 different layers. With this particular study, the Eastern Indian Basin, where the Damo, Jabera, and Nohata area has given the high level hydrocarbons, which are the actions now which have not been seen. So basically the fault which is running through the Jabera fault is acting as a sealing fault, and from there the hydrocarbons could not be going into the central level, and then eastern level anyhow is more smoother, wherein the tectonic disturbances could not happen for the hydrocarbon entrapment, whereas mafic dikes are already there, volcanic mafic dikes, and mineral exploration part of view, the central part is already very well taken care of. Future scope is very good because the study of the gravity magnetic levels and the crustal levels has given us opening up a new idea about studying these into 3 different parts rather than taking it as a single one. the overview of the total idea could be get from this. Finally, pranam to all my professors and mentors who guided me, and I am Geophysics. I am from Andhra University and from IIT Bombay. So then my learned MSc Tech batchmates support always make me feel I'm in early 20s, the energy comes from them, thanks to them. Then my batchmate support always makes me happy because we could pull out funds for digital classroom in the department which has already been announced. Thank you so much. Any questions? Due to past time, no question. I request Sri N. Chandra Babu. I think I have seen somewhere. Sir, come to your presentation. Is that better? Can I request our Guru Ramlingeswara Garu to continue because Chandra Babu will take some time. Okay, Ramlingeswara Garu presentation number. My presentation Japan, Japan.
Yeah, seismic zone map of India.
Good evening to everybody. I'm old student of this Geophysics department and it will want to. I was taught by and some other eminent scientists are there, Indian professors. They made me to work on seismological work. Professor, diagrams are there in the department, in our department. We did some work in Japan and that is in seismological work. Nobody did afterwards. So I have taken seismology as my research problem. So please. So, my main motto is here to present you the new seismic zoning map of India. Why do we need that new seismic zoning map? 2002, the PAS published the 2002 seismic zoning map of India. We got the legal data set. Afterwards, I have the necessity for the new seismic zoning map of India because of multi-floor and the strikers have come up. Apartments in Hyderabad, even in Visakhapatnam, and we need to study about the seismic zoning map of India. And we have to establish the new methodology and new future generation, especially for the civil engineering. We are the seismologists to give actual approximate, at least approximate value of the area in that in that area. So, this is my subject. So they are giving me 7 minutes. Of course, I will ask you that. I want to identify, make a low, medium, and upper seismic zones. Explain the usage of new seismic zones. And explain the growth of how it is. Explain the seismotectonic and define the response spectrum and the probability for prospective like that. We need to have open just probability and India about 95,000 activities are planted, right? And data will give us from blue to the have cycle going on. Related so we got it. That was essentially. But why you are getting seismicity into also. Backward stresses accumulated into number of parts and so that is what receiving this stress, the how to identify and identify the goal. I collected all the data, implying that the builder data and the person data, this is data. Data was broken. They are seeing data could not do anything, but it has given needs. Data was broken. Another data is not still broken. And this is also active, interconnect. So we need that indicates that can you accumulating itself and make movement. In the development by using the data set by Graham, to identify the how this framework developed in our data, what type of magic would be after the following. I did that yesterday here under Kitabatrao and at that time there is no other word, only this. So this is equal to value into probability into other. To work on this is in the name of the hazard in that time. So I give you in today this is value. Today, like how it is value I will. So I collected the 45,000 aspects and I will like the 55 more than 55 to 60 isolational runners I selected. I decided all the data and found that this is the maximum failure or maximum intensity data. So in the I was asked by people that I was a member in the Geo Physics bandit. They asked there a problem with to develop a new technology, develop a new technology of India. This can be enormous capital. So I collected 45,000 events. So I made an attempt. 55 students from approximately. I visited and made the data set into Geophysics. And generally, theories are helpful. Actually, we don't have archaeologists throughout India, not even Andhra. But first, the kind of first man, I know, Dr. Kumar is the first man who identified, who had a scientific knowledge of people. So identified. So afterward, taken for good now. So how to do Indian gravitational primary and like that middle damage and higher damage, more higher damage. So I have developed myself. All the challenges including all the size, but magnitude and intensity and Dhoni, this is the angular, but identifying the angulation, attenuation for different locations in India, all over India, and then a comprehensive method. This is a book by me. This is don't factor island, right? And there is don't scientifically. Usually they have their isotonic value, isotonic magnitude, isotonic intensity, but what is the case? We have to give physical meaning of it, don't and don't time. This is my so I do that. Sorry. Don't naturally get up to the creation also. Upon this totally, I think it's also like you will have a spectrum of things. You talk to kilometers, close the 6 hours of things and happen. I think that you have to dependent frequency dependent. 500 kilometers total. Yeah, that's 1 feet, 5 feet, 5 to 3. It is more endless to be happy totally. Frequency. So this is based on these values are prepared. So actually there is a tool. You have to use these concepts from the good. But I made it. I tried to use civil engineers. They will move to that of the country to take become the flight. And 3 maps are prepared. So 3 maps, you take up 1 point from the same place and borrow your own pen. And really, in that building, maximum sequence of the ground should not be equal to the sequence of the multiple building. If those are equal, so the land should increase and this will fall. It will be relaxed. Maybe thank you. This is my
Thank you, sir. The pleasure to listen to you. No question, please. I request N. Chandra to take over.
Respecting everybody, I am N. Chandra Babu, retired ONGC DGM Geophysics. Hello. My topic is today fundamentals on oil prospecting. Thank you to the Department of Geophysics for the giving opportunity. Yeah. So God is very important. Everybody, worship is very important. This is our temple structure. Ganesh, Shiva, Rama, and Anjaya and Lakshmi Devi. Money is in between. Next slide. Next. Okay, sorry. Now this is our exploration geophysics. Is on the left side. On the right side, Arca beach of Visakhapatnam is there. In the down, the Arakuloya of Visakhapatnam is there. And this is Simhachalam temple where king is God. In between, our national flag is there. Wherever we are, we have to identify the landmarks of that particular place. This is the landmarks of the Visakhapatnam. And this is their oil and gas accumulates on anticlines, fault closures, and salt zones, and stratigraphic traps, and refund traps. And gas is lighter than oil, oil is lighter than water, and anticline is modeling from geological model to the seismic trace, is the forward modeling. Inverse modeling from seismic trace to the geological model. This is our Earth is divided into horizontally onshore and offshore. Earth is divided into three components vertically. That is first mantle core, and those are the faults, normal fault, reverse fault, etc. And these are the seismic signals from three layers and summed up, stacked up there. This is the Snell's law. Refracted ray, reflected ray. Reflected ray is very important. Seismic reflection is very important for oil and gas. And this is 3D geometry. And this is 3D geometry, square, inline direction, cross-line direction, receiver interval, receiver line, source line, receiver interval, source interval. This is a 3D geometry. And this is our stratigraphic time scale. And in the recent age of the man will be there. And next, in Cretaceous, dinosaurs are there. And in Carboniferous, amphibians are there. And in Jurassic, flowering plants are there. And first forest is existing in Devonian. And the age of life is not existing in Precambrian. And these are the noises when you are going to the seismic reflection data. Ambient noise, coherent noise. The noises are direct waves, ground growth, air waves, shallow reflection, reverberation, multiples, and diffraction. And traffic, wind, earthquake, higher noise, short wave, instrument noise. These are the noises. At the processing and at the acquisition, you can improve the signal to noise ratio. And this is the seismic signature for an anticline where oil and gas is there. And this is the interval velocities for petroleum, water, mud, shales, sands, carbonates, dolomites, igneous, saltons. These are the interval velocities. These are the multiples and which can in the seismic processing. And this is the geological time scale. Our Earth is 4.5 billion years. And this is what is seismic processing. In the processing, data reduction, geometric correction, data enhancement, additional processing. Under processing, under data reduction, multiples, gain recovery, editing, summing, cross correlation, gain function. And processing at the geometric correction, CDP sort, datum statics, NMO correction, residual stack, residual NMO. At data enhancement, mute, stack, bandpass filter, notch filter, deconversion, 2D OD filter, recirculation, loss migration. In 3D what happens? Some what you will bring together, some what you will I'll show you. 1 minute. This is in 3D sequence, the processing just like a 2D only, but slight difference will be there. At being gathered, 3D NMO statics, migration X, Y direction, post migration products, inlets, cross lines, public lines, side start, etc. And this is the time scale particular. This is well logging. Well logging is very, very important. Well logging is very, very important in the island because it is very near by the well column. That is the well column. This is the well column. Nearby the well column, we take the logs. We take the log studies, which are very, very accurate beneath the surface of the earth, not above the surface of the earth. Well logging is very important. Wherever sand is there, the anomalies are noticed. Wherever anomalies are there, you have to be triggered there for oil and gas. And these are the over different wells situated in KG offshore for variation section. Here variation section, and this year, this one well is here, one well is there. So the variation depths are different. This is TD time depth table. What you from time domain to depth domain to time domain, you can convert. Here, VSP is very, very important. VSP, where it gives the whatever time domain to the depth domain to the time domain. Where seismic projection can be carried out from this by using this time depth. These are the contour maps which we can make after collecting the seismic reflectors in the particular zone. And this is the weather layer. Weather correction should be applied below the weather layer. Source should be placed, not above the weather layer. The dissipation will take place. These are the sea level rises. Wherever sea level fall is there, wherever sea level rise is there, seismic signatures can be noticed. On the ocean, whenever depression comes on the ocean, rainfall will come from the sky onto the ground. And these are the seismic section for oil and gas complex. And this is a typical seismic section of the KG offshore. And for showing you, this is a seismic section. This exemplary seismic section. This is one more seismic section, exemplary seismic section on KG offshore, showing the picture. And this is my abstract. I cannot read abstract, time is over there. But this is abstract. Abstract has printed there. You can read the abstracts. And these are the references. And one suggestion to the students, you make the video, at least one video on geophysics, on any topic. Out of 2 years, you can make one video and put it in the YouTube. Everybody. Thank you.
I'd like to listen to you anytime. I request Rajbabu to please stop.
Point. Hello. Good afternoon, sir. Respected my professors, my seniors, and my juniors, ladies and gentlemen. Myself, Raja Babu. I am 85-88 batch. Presently, I am in Central Groundwater Board. Next. So actually, we received one message from Vice Chancellor Andhra University for conducting groundwater surveys, GP surveys for groundwater. So to cater needs of the university for various purposes, groundwater. So their existing resources available for them not sufficient. So to generate extra resources, we planned some geophysical surveys, and apart from that, we planned some recharge structures also in that area. So this is the location map of the university area. Actually, it is around 95 acres area. This is the layout. So, geologically, the area is covered by alluvium, and it is the area is underlined by topsoil, Rajahmundry sandstones, Deccan tracts, Tirupati sandstones, followed by Archeans. The thing is actually that the Rajahmundry sandstone has been totally dried up because of this over exploitation. Recently, in our report, groundwater assessment of the Andhra Pradesh area, this area comes under over exploited area. And the water levels also, it is around 60 meters from the surface. And the normal rainfall is around 1,211. So ultimately, how do we create that additional resource of water? The source is only rainwater. We have to utilize the rainwater and collect the rainwater, arrest the runoff, and we have to make some recharge structures, and we have to make it infiltrate into the surface. So actually, actually our main two things there are two aquifers. That is one shallow aquifer, which is Rajahmundry sandstone that has been dried up because of over exploitation, and it is followed by Deccan tract. So it is impervious. So there is no chance of groundwater in that tract. And it is followed by Tirupati sandstones. So there are two. One is shallow aquifer for recharge that shallow aquifer, and for a deeper aquifer, it is for making a bore well. There are two bore wells. So because of that, Tirupati sandstone gives water. That is the available source. So this is location map, and actually here we conducted 9 vertical electrical soundings, and we conducted two sections. One is for electrical resistive tomography, two sections, and already there are tube wells are there. Those tube wells also actually we correlated our resistivity data with the drilling data with the result of samples, and we correlated and assigned the resistivity values for each layer. So this resistivity resistivity values correspond to that layer by correlating the lithologs in that particular drill bore wells. So actually we generated two sections for shallow aquifer. So this is the A section. It is west 4 to west 1. It is the Rajahmundry sandstone is 40 meters thick and minimum at 9 meters. And same as in PB section, that two sections are we taken. There also it is 87 meters. It is thickness. The Rajahmundry sandstone, and that less it is around 20 meters. That is also very much important. We need the thickness is important there. So for deeper aquifer also, you see here, in this there is no Tirupati sandstone. Rajahmundry sandstone it is followed by trap. Here, that Rajahmundry sandstone followed by trap, and it is further and Tirupati sandstone. So this is deeper aquifer. So we require this Tirupati sandstone to make a bore well. So actually we prepared using Rockworks software. We prepared this 3D section also, and the thickness of the range it is given, and Rajahmundry sandstones it varies from 9 stones. This is also for deeper aquifer. This is for shallow aquifer, and this is for deeper aquifer. No, actually, so 3D. It's not coming.
Sir, I will
It is coming. So actually, the 3D view in different directions, how the formation, the thickness of the formations are varying from this different directions. The topsoil, Rajahmundry sandstone, Deccan trap, and Tirupati sandstones. So actually, we conducted ERP. This is the ERP. One is 400 410 meters for shallow aquifer and for 810 meters. So ultimately, 1/5 of the spread length, 1/5 of the spread length gives the depth of that particular formations. So summary, the topsoil varies like that, 1 to 4 meters, Rajmani sandstones and Deccan traps and Tirupati sandstones varies from 8 meters to 125. That means 80% we are utilizing and 20% we are wasting. And the peak runoff is this one, and number of rainy days generally we have taken 30 days per annum. So ultimately, that annual around 8,500. So for that 14 recharge pits we are planning, we are proposing to send that much of water for infiltration purpose. And for that is for ongoing works also, that 8,564 meter cube of water we are generating. Ultimately, by doing this, the needs of the water for Andhra University that has been fulfilled. So this is the it's not coming. So that is rooftop area. We are collecting water, and this is the pipe. We are sending water. This is the filter, and it is going. So this is the pipe. That is the structure. So propose 14 recharge pits for existing buildings and 7 recharge pits for the buildings. Rooftop formation structures are to be connected to recharge pit and recharge shaft. So this is the plan. This is the structure we are proposing for Andhra University. So these are the recharge pits recommendations. Actually, we have this type of structures are available in our office in Hyderabad. So that is a proposed 3 check dams, and these are the 1 galvanized structure and 4 rockfill dams. These are the things are proposing. Once these are constructed, and we have to see their impact of these structures on groundwater by measuring that water levels in that area. So these are the field photographs. Thank you.
Thank you so much, sir. Because the time is not there. Sorry very much. One question, sir. Sorry.
Tirupati sandstone, for us to produce water.
Yes, sir.
It is good.
Yes. Actually, we are not comparing from the sandstone only.
I see.
Yes, there is no water in running sandstone because that is a dried up.
But we can recharge.
Recharge. We can recharge because that over exploitation it is under OE category, over exploit category. So unless we recharge that aquifer, the recharge purpose is good because that it is followed by Deccan traps, which is impervious. So that in that area, it is that infiltration purpose is very good area and low surface runoff.
For recharge.
Yes, sir. Kindly. Mr. Mahesh. Mr. Mahesh. Sir. Come.
Good afternoon, everyone. Hope I'm audible. So, as part of this national conference, I'll be delivering a talk on climate change, greenhouse gas monitoring on the Indian region using Earth observation systems. So, about myself, I'm Dr. Mahesh, and I did my PhD very recently from Jubilee, Hyderabad. I joined NRSC ISRO in 2011 after completing my BTech in Physical Sciences from Indian Institute of Space Science and Technology. Currently, I'm in Scientist F at NRSC ISRO Hyderabad, and my area of research is the greenhouse gases, global warming, and climate change. So today I'll be talking about the Earth observation systems for monitoring the greenhouse gases using the different platforms. So this is my responsibility as a team at NRSC, myself and Dr. Maharashmi and Kanchan, our team. We are working on these are the major project activities we are taking up, like atmospheric CO2 retrieval and monitoring as part of ISRO Geosphere Biosphere program. And as part of this, we have established a dedicated observation network to understand the CO2 dynamics of the Indian region. And also we are continuing the polar research expeditions, and myself participated in 35th Indian Scientific Expedition to Antarctic and also Arctic, and my colleague Dr. Maharashmi also recently participated to Antarctic expedition. So here we are studying the atmospheric CO2 dynamics and teleconnection with the mainland, because the major climate change happens over the land, and how it is the Antarctica, the emissions, the concentrations of Antarctica and the linkage to the main emissions over the globe. And also we are conducting airborne campaigns to study the vertical distribution of CO2 in the atmosphere, because these emissions are mainly driven by the surface characteristics. But whereas because of the atmospheric process, especially convection and advection process, the surface composition will uplift to the upper atmosphere, that is the mid troposphere. So to study that exchange between the surface to the troposphere, we are conducting an airborne campaign, and also hyperspectral imaging sensor for estimating the methane and other GHGs. And as part of ISRO GBP Geosphere Biosphere program, we also established a dedicated CO2 flux tower. So as a function of different land use, land cover. Basically, depending on the ecosystem, we have established CO2 flux towers across the country from south to north. Even the Gulmarg site in Kashmir, in the glacier site, we have installed very recently CO2 flux tower. We are also studying the air CO2 fluxes, how the atmosphere and ocean are interacting with the atmospheric CO2, and land use, land cover implications on GHG emissions also we are studying. And the international efforts towards the monitoring and the studies of greenhouse gases, ISRO and JAXA Japan have come together, and we are going to work soon on the calibration, validation of satellite-based GHG observations, and also the ISRO is participating in the CalVal activity, and the JAXA has the GOSAT and GOSAT-2 series of observations, which gives continuously CO2 to the space. And we are also doing, because we are collecting a lot of data from observations and also satellite data. So to estimate to quantify the carbon emissions with less uncertainty, we need to assimilate these data sets to the Earth system models. So this project we have taken up with the Indian Institute of Science very recently, and we will be delivering this, like the assimilation of the ground-based and space-based observations to the Earth system models, so that the quantification of carbon emission as a function of land use, land cover, the climatic zones will be more accurate compared to the conventional method. And also we are launching the balloon experiments to study the vertical distribution of ozone as well as the meteorological parameters, which drives the many things in the atmosphere. And I think like yesterday our directors also spoke about the climate change, and today our deputy director also talked about the climate change and the natural as well as the anthropogenic. Natural has its own balance over the time, but anthropogenic influence is the major concerns today that everybody is talking about the climate change. So anthropogenic emissions are mainly driven by the GHG emissions and the aerosols. Aerosols are two types of aerosols in the atmosphere. One is the absorbing aerosol, the scattering aerosol. Whereas the absorbing aerosol has the positive effect on the climate system, because it absorbs the radiation and keeps the atmosphere warm. But whereas the scattering aerosol, it scatters back to the space so that it cools the atmosphere. So that is why these are the major change driving factors of climate change when it comes to the atmospheric composition. Greenhouse gases, especially the carbon dioxide, methane, water vapor, and nitrous oxide, and there are many other like chlorofluorocarbons, other things. And these are very popular curve. The person who first started the CO2 observations on the globe, 1950s, Dr. Keeling. This is a Keeling curve. Popular, it is known as a Keeling curve after heat. So these are Keeling observations. 1950, the observations, the concentrations were around 310 to 320 ppm. But today, if you see the emissions, the levels of atmospheric CO2 in the atmosphere, we have reached up to 425 to 430 ppm, and the global mean close to the 430 ppm. The amount of this shows the acceleration of the carbon emissions across the globe, and we I hope you are aware of representative correlation pathways, RCP's projections. Under the 1.5 degree scenario, that is mostly use of renewable energy and the adjustment in the lifestyle. There are many factors to achieve this 1.5 degree scenario projection. So if we have this 1.5 degree scenario, the net carbon emissions will be very much possible for 2070, which the government has also the international agreements like Conference of Parties, which we are everybody, many countries, more than 180 countries have signed to reduce the carbon emissions across the globe. So this 1.5 degree scenario is only possible with a lot of adaptations and the spending of renewable energy. So these are the implications which are having the positive effect of the greenhouse gases like CO2, methane, and other chlorofluorocarbon. And the negative, the blue bar shows that negative impact. That is a cooling effect which does not have any impact on climate system. These are the series of greenhouse gas satellites which are available today on from the space, and these are the like a comprehensive way to understand the impact of GHG emissions across the globe, like use of ground-based observations and airborne measurements, UAV platforms, and using the satellite observations. These are efforts like internationally people have taken like establishing a dedicated ground-based observation network, and ISRO has also established many flight servers as well as the ground-based observations. These are ground-based observations set up with ISRO, like Karnataka, which represents the forest, and Kavareti represents the ocean, and Kolkata for urban side, and also the Jammu Kashmir for the glacier side. And this is the first of its kind in the country that we have Fourier also infrared spectrometer. We can measure the spectrum from the sun is the active signal source for the electromagnetic signal from 0.9 micrometer to 16 micrometer. Using this spectrometer, we can collect the signal and we can retrieve more than 10 greenhouse gases in the atmosphere. So we have also put the efforts to validate the satellites and also to study the urban-suburban interaction of these greenhouse gases as well as the pollution. And the GPL team visited our lab to see this facility. And this is the system that I was talking about. Like we have all these types of data like ground-based, airborne, remote sensing, and also the supporting data from the meteorological and some inventories, fluxes. So when we feed this data to the climate model or regional model, depending on the interest, so we'll be able to identify like identification of hotspots of these GHG emissions over the Indian region, and also to see that the spatial pattern of these GHGs, and also to estimate accurately the carbon cycle. And this information will be useful for the policy decision makers to take the informed decisions. These are some of the platforms I will quickly run through because so these are bureau launching experiments we are doing from different parts of the country, and airborne experiment to study the warming effect. These are profile like the typical profile of atmosphere CO2 in the atmosphere using our NRSA aircraft. We have measured different locations, the vertical distribution of CO2. And this is I like it most because it is a very evidence for the climate change, the rapid emissions of carbon from southern hemisphere to northern hemisphere. Once upon a time, the gradient was used, but if you take in 2022, northern to southern hemisphere, the gradient has become very normal. There is no difference between southern hemisphere emissions and northern hemisphere emissions. These are some of the studies like we have taken up on methane and methane over the coal fields, thermal power plants, and wetlands, how they are contributing for these emissions. And this work we have submitted recently to the Science Advances, the Science Journal. So how the carbon emissions as a function of land use, land cover is over the Indian region, which was submitted recently to the Science Advances, which is under review. And you see this like from 2010 to 2022, methane emissions around 2000, the concentrations were 1700 ppb, that's a parts per billion volume. But now 1950 ppb parts per billion volume in 2020. That is the level of emissions that are increasing to the atmosphere. And also the satellite technology has improved to see that source level emissions, how they are contributing each source type. These are the polar research expeditions that we are doing, and we can use the hyperspectral imaging sensors and airborne campaign, and also some of the sensors to do these studies, even from geological study to atmospheric composition using the hyperspectral sensor. These are International Space Station that we detected leaks of methane over the hotspot regions. I think with this I'll close. Thank you so much.
hours per month. Yes, we are 30-meter towers. These are all 30-meter towers.
Thank you, Mahesh. Okay. Professor K. Satish Kumar is there in the hall. Sir K. Satish Kumar from CSR NGR. Next, U. Uma Devi from CSR NGR. Professor Hasib Rahman from Department of Geophysics. Okay. Mr. Chitram Venkateswarlu. Yes. Your time 7 minutes. So 6 minutes again. Yes, sir.
Good afternoon to everyone. So my name is Chinta Venkateswarlu. I am a research scholar in Department of Meteorology and Oceanography. So my topic is smartphone cameras and numerical models to identify the rip current studies. Around Visakhapatnam, RK Beach and Ishikonda. So this is my study area, study region. Actually, my focus zone is nearshore regions. So coastal zones are very important. Coastal regions are very important for different aspects like mineral explorations, dredging purpose, defense purpose, coastal engineering applications, tourism purpose, recreation purpose. Like many aspects, coastal regions are very important, and coastal regions are more dynamic and complex system of the Earth system. So almost 44% of the people are living in 4% of the Earth's land area occupied in the coastal region, and 11% of the world's ocean occupied in coastal region. So particularly this is my main focus zone near up to nearshore, breaker zone 1. So these are, in nearshore region, rip currents are the major natural hazards. So due to this rip currents, lot of drowning deaths occurring in the Visakhapatnam regions only. So in the last 10 years, almost 600 people died because of this rip current. So that's why I focus particularly this rip current. So actually waves are coming from the offshore towards the shore, but here after wave breaking, so wave-induced currents will generate. So after wave-induced currents, it will move towards the parallel to the coastline, and it will call a longshore currents. These longshore currents plays a major role in sediment transport from one place to another place. So wherever the channel is there, so those two longshore currents converge and it will move towards the offshore. Like here, sorry. Here the dye is moving towards the offshore. We just deploy a dye at the subzone, and wherever the channel is, automatically the rip current will move towards the offshore. By using traditional methods, it is time consuming and expensive. So the alternate method is remote sensing. Remote sensing, it is giving good images and accurate high resolution images, but it has some limitations like atmospheric weather impacts something. So we are planning to actually we thought deploy a new innovative method. Like we are taking videos by using smartphone camera. We are fixing a camera at top of the building. At RK Beach, we are taking videos from morning 6 a.m. to evening 6 p.m. from this building. Like this is the sample image collected from the smartphone, and this is ultra wide angle camera. Mobile camera, it has two advantages, two camera lenses. One is main angle camera and ultra wide camera. Ultra wide camera gives the wide area, so that's why we are trying two different cameras. Actually, videos are recording by like this. So we are recording the video for first 20 minutes in each hour from 6 a.m. to 6 p.m. So after collecting videos, we need to process as a scientific purpose. We are converting the individual image frames. In 20 minutes, we are converting 2,400 images as a 2H frame rate. Actually, every camera it has some convex and concave shape natures. Like we need to remove that distortion errors. For that, we took a checkerboard images to calibrate the camera to remove the distortion error. We took almost 25 checkerboard snapshots with different angles, and we calculate the camera calibration. Here, the pixel array is almost less 0.01 x and 0.017 x position and 0.19 y position. So it means it is accurately calibrated camera calibration. So actually, camera gives the local coordinate images. So we need to rectify the as a satellite image. So for that, camera calibration and GCP ground control points are required to rectify the spatial image. So these are the based on this image we can rectify the local coordinate image to geospatial image by using this collinear equation. In this collinear equation, we are fixing the intrinsic parameters and extrinsic parameters collected from the observations and calculated intrinsic parameters from the camera. So those 11 parameters are applied to rectify the local coordinate image to one coordinate image. After rectifying, it is giving the two methods. One is world coordinate and another one is local coordinate images. These local coordinate coastal community is accepting and local coordinate images. It is giving good information from the image. So from this image, we can identify the all features from. This is actually timex image. Timex image means 20 minutes average image. So in this image, we can identify the shoreline features and if any subzone features. And if any beach concepts are there, we can identify the beach concepts. Wherever the channel, mainly we focus to identify the rip currents from the image. So we are targeting the rip currents from the image. So we can clearly observe that this dark gray channel indicating the rip channel. So in this one kilometer stretch of the area, we identify the 5 strongest rip currents at RK beach. So again, we are extracting the nearshore bathymetry by using the video image. So the grid indicates the bathymetry location. That yellow line indicating the cross-shore transect and orange line indicating the along-shore transect. This along-shore transect will help to extract the long-shore currents from the video imagery. That yellow line indicating will help to identify to extract the nearshore wave parameters: wave height, wave period, and wave direction. And as well as the wave nearshore bathymeter. This is we can clearly observe that the rip channel, how it is intensified. Actually, it is started in the Kalimata temple at RK beach and it's traveled almost 250-300 meters from the shore. This means very strongest rip currents. If anybody caught in this rip current, automatically the people panic and he may be died. So that is the main important. Here we also deploy a rhodamine dye to identify the rip channel by using visual observation. This rip channel dye is also clearly observed in the timex image, as well in the cross-shore and time-stack images, along-shore images. We can clearly observe the advantage of video imagery. We can see different type of beach parameters, different type of beach stages. We can identify from the timex images. How it is changing regularly. So by visually we can identify, but the advantage of video imagery, we can prove them to this is the stage of beaches. That the dark channels where the rip currents are not, we confirm by using the along-shore transect. That wherever the dip indicating the confirm that is the rip currents. We confirm by using the along-shore transect. And we also calculated the rip current risk estimation by using the wave parameters. These are the locations we are calculating the Visakhapatnam region. Very risky zones are low, moderate zones are low, safe zone. And also nearshore bathymetry is one of the main important parameter in nearshore regions. So for that, in-situ observations is a challenging task, and we cannot take measurements near to shoreline. So the advantage method is satellite derived bathymetry. We extracted bathymetry from the Sentinel-2 images. The advantage of Sentinel-2 is it is giving near to the shoreline. we extracted a bathymetry from the satellite images, and this bathymetry given to the numerical model. And whenever the channel is occurred, at the same places we predicted the rip current by using this X switch model. At the same location, the rip current was identified. This is one of the important parameters because lot of draining deaths are occurring in the Vishakhapatnam beaches. In the simulation scenarios, I already done 1500 test scenarios, how it is changing regularly with varying wave parameters, significant wave height, wave period, and wave direction, spreading factor, and tide also. We incorporated model and we identified almost same rip channels observed in the Timex images, and the same results predicted in the model simulations also. This is R1, R2 indicating the RIP 1, RIP 2, RIP 3, RIP 4. In the span of 1 kilometer state, there are 5 strongest RIP currents, 2 or 3 small RIP currents are there. So, for the first time in India, we established a RIP current warning board at Rushkotna beach. So, it is giving forecast, we are giving forecasting regularly every 3 hours. It will, the data will update. But the first time in India, we established a warning board system at Rushkotna. Some of the public awareness by using newspapers and television something. Thank you.
An excellent presentation, Venkateshwar.
Sir, thank you.
People will ask now.
Okay, sir, thank you.
Yes, one question.
Yes, sir.
Current changes from time to time?
Yes, sir. It will change. Sir.
24 hours, one changes?
No, actually, it will change regularly. In 24 hours, it may not change rapid changes. It will change little bits.
Okay, thank you so much. We are calling Mr. Rahman. Before that, Mr. Calling, before that, I said.
I request Professor K.V. Sachinathan sir, please come to the dais. Accept our felicitation. I request Professor V. Venkateshwara sir, please come to the dais and please state the K.V. Sachinathan sir.
When we are conducting examination, institute examination, he was our Edgar was not working. He helped me a lot.
Thank you Mr. Rahman, please. 7 minutes, sir.
My teacher, my alumni, and students, good afternoon to all. So today I am going to present the work that is related to the seismology, serpentinization of the upper mantle and evidence of lithosphere discontinuity getting to the Western Indian Ocean of the seismological depth. So this is my study area. This Western Indian Ocean is my study area. So you can see there are it's have evolved since from 180 million years during the late Jurassic, and it is in present form since last 36 million years. So you can see there are a lot of fractures, and you can see the volcanic hotspots cracks from 15 million years to 10 million years. And we have a David Rees, all those things. So I have tried to study the subsurface structure using the radiator. So you can see that wave paths are there.
From this is rainfalls, I have divided it into 4 clusters, W1, W2, W3, and W4. These are the rally wave paths. So along these paths, I have calculated the rally wave dispersion curve, and again I have inverted for the shear wave velocity structure. So this is the flow chart how we will calculate the rally wave group velocity. So initially we will do some processing and then we will apply multiple filter technique, and then we will calculate for the group. We will calculate the group velocity, and using the phase matched filter we will isolate the fundamental mode. So I have used the fundamental mode rally wave group velocity. So for the inversion of this rally wave group velocity, I have used the neighborhood algorithm. So prior to the using the neighborhood algorithm, I need a reference model. So for that, what I have did, I have initially find the gradient in the velocity structure using the least squares technique. So that is best suited for the find the gradient in the subsurface structure. So based on those gradients, I have divided the subsurface layers. So again, that 6 layers I have given as a input for the neighborhood algorithm. So neighborhood algorithm contains 2 parts. First one is we will invert for it, and second part we will do the basin analysis for the appraisal of the model. So these are the dispersion curve. I have compared with the GD M52 model dispersion curve, and observed dispersion curve shown with the red dots. And the theoretical dispersion curve, after I inverted using the neighborhood algorithm, was theoretical dispersion curve indicated by the green color, and the standard deviation in the observed dispersion curve or the error bar indicated here. So here the resultant model using the neighborhood algorithm. So along the each path, I have extracted the average litho model, and I have compared with that. So you can see I am getting low velocity zone here and here, and these both are the lithospheric structure which have velocity about 4.6 kilometers per second. Shear velocity. So this is the appraisal part. After doing the inversion, I have checked for the appraisal. These are the Gaussian distribution. But this middle line represents the posterior mean model. So again, this is the posterior marginal density functions. So the more circular is your contour, that is 95% confidence contour. So in between triangle is there, that is the posterior mean model. So it is saying that my model uncertainties are very less. So earlier using the same neighborhood algorithm in another region, we got uncertainty in shear velocity about 0.1 to 0.2 kilometers. That is good. But in my studies, by selecting the appropriate initial model, I got about 0.05 kilometers per second uncertainty in this shear velocity. That is acceptable. Furthermore, in earlier studies, we have inverted only for single depth, that is model. But I have inverted for both shear velocity and depth in each layer. So this is my results along the four clusters. I have joined the inversion result. I have joined it to take the 2D model of this subsurface structure. So here you can see this is velocity is low. So I have attributed it to the serpentinization of the upper mantle, because the velocities are about 3.8 to 4.02 kilometers per second. Using the empirical relations, I am able to correlate it. And another thing, that the geological conditions are favorable for the serpentinization of the upper mantle. That is the presence of the faults and fractures, all those things. So there is a possibility the water may got into the upper mantle, that is the ultramaric block, and it with time got serpentinized. So after that, this is the lithosphere structure. Lithosphere means upper mantle. This is the upper mantle. So I have seen this low velocity zone. So this low velocity zone is the first time that I have got in the Indian Ocean. Earlier research are there, but they didn't show any kind of this low velocity zone. But these low velocity zones are present, studied mostly on the continental part. That is called mid-lithospheric discontinuity. And they also studied in Africa, this one, Atlantic Ocean and Pacific Oceans. But this is the first time that I have able to get it using the data. And another thing is the tomography models also there, but they also didn't able to recognize. So what it's saying that even I have did early modeling those all things, but still it is relevant. Because in a tomography model also is depend on the emission model. So if you ask them what is the from where you have taken emission model, they will say from X order. So I am not with that. I have to find the gradient in the sphere velocity. That thing I have used as a initial model for the Niagara algorithm. So here you can see here there is some breakup is there. Continuity is not there here. So here there is a presence of the, it may be there due to the effect of the plume activity that is happened in the past along the path W. So same I have correlated with the VP by VS ratio. So for serpentine elevation, I got VP by VP ratio about 1.8 to 1.94, and for this mid-lithospheric discontinuity same I got from 1.89 to 1.91, and this is the low velocity zone atmospheric. So the shear velocities and their empirical relations and the VP by VC ratio are correlated with the studies in the Pacific Ocean. So their depth of low velocity is MLD. Mid-lithospheric discontinuity fall under the 50 to 90 kilometers. Within the same range I have got here. So this is the last slide. So MLD, how it forms, it is available in lot of the literatures. So when the melt flow, what happens? It will get accumulate here. Not all the melts that will come up that reach to the mid-ocean equals to form the new crust. Some of them divert into this atmosphere itself, and some of this get deposited here. And as it gets old and the plate travels, it get trapped and travel with. So all the geological correlations and empirical correlations, those are the favorable for the showing that ML is the most favorable condition that we can explain for the results.
They are for gradient waves.
Yes, sir.
Gradient waves are surface. How do you say they travel to be and to go on the gradient now?
Sir, it is up to 250 kilometers, sir. That I have shown the model.
Just only travel along the surface. They don't go on. They are very low frequency.
No, sir. Low frequency, but they travel up to the, they haven't traveled up to the upper mountain 400 kilometers. No, sir, that energy dissipated with depth, not exactly travel on the surface. The energy dissipated exponentially with depth.
What is the source of the gradient wave?
Source of the gradient wave earthquake, sir. Earthquake, sir.
So when you get sector, you study it.
I didn't get, sir. No.
You will study in detail when the earthquake sector.
At the earthquake sector at shallow depths.
Sir, Professor Rahman will explain.
No, sir, Professor not
in the sir. Okay.
And yes, okay.
Anybody from IIT Kharagpur? Professor M.B. Prasad Raju? And R.K. Chaudhary from Andhra University? A. Dharmaraju from IIT? A. Dharmaraju from IIT? Okay. Then U. Nanaji from CSIR, NGRA? U. Nanadi from CSR NDRA. And not you are the person knowledge. Please don't respond. Not them. Geo Bharati from Andhra University. And M. Jyoti Prakash from. Okay. And coming to Sirisha J. Corporate. Okay. P. Pradeep Kumar. Anwar. A.V. Satyakumar from CSR NDRA. Rajesh Rekapalli from SCR NDRA. Come please. And okay, come. Sarat Kumar Mandal from NDRA. No. Then T. Anil Kumar from AU. Thank you. Okay, Rajesh Rekapalli. Please come.
Please, silence, please.
Thank you very much for giving me the present before the Geophysics as well as eminent professors and lecturers. Today I am going to present a very novel topic. There have been listening that seismometers can be used to yeah. Am I audible?
Yes, sir.
Okay. So you have been aware that seismometers can be used to monitor the aspects only, right? So, but the seismometers also record the signatures other than the aspects like landslides, other debris flow movements, and floods also on. So, at the environmental seismology group of the CSR NGRA, we have been working on developing a robust early warning system for landslide monitoring for the Uttarakhand Himalayas region. There we have started, and I think I am audible to all of you. I don't have the mic. But it is very clear from the global scenario. Yeah, it is very clear from the global scenario that lot of people, like 4.5 million people, are suffering due to the landslide activity annually. If that comes to the Indian scenario, we have been observing 28% of the Indian landmass is vulnerable to the landslide activity. So, because of these things, it is very clear that there is a need for the development of the landslide early warning system. But what are the present technologies that are available to develop the landslide early warning system? So primarily the satellite imaging technology, which will provide us the satellite images of the surface, and where we can demarcate the landslide activity from the time-lapse images. But however, this satellite technology is not sufficient to provide enough temporal resolution. Like if you want to scan the same region for 2 times lag, there will be a lag around 2 to 5 days in the present scenario and the technology available in India. And similarly, when we look at the in situ measurements, many of these landslides will occur on the mountainous regions which are inaccessible. So we cannot reach the mountainous regions and install the in situ sensors to monitor the landslide. Because of these two things, we cannot use the satellite technology further. And if you look at the seismic signature, like if you place the seismometer away from the landslide active zone also, it will record the signatures. Not only seismic signatures, it will record several signatures. You can see an example of a bunch of signatures recorded other than the earthquake. You can see here, this is the rock slide signature, and debris flow signature, and bed load change signature, and this is a typical earthquake signature. You all know this. And ancillary noise, like ancillary noise means some instrument motion as well as car motion, and like if a human, a crowd of people are moving near where the seismometer, as well as animal motion also cause the signatures of seismic elastic waves. So they will be recorded with the seismometer. In this way, if you look at the landslide signatures, you can see here is the spectrum of the signature. Here I need to explain because I will have to complete the. So you can see here, when we look at the time domain, they all look like almost similar. But when we look at the frequency domain, it's very clear they are having a distinct frequency spectral characteristics. But however, if you compare that with the landslide spectrum, like spectrum of the landslide, that is power variation with time at different frequencies. If you look at it, it is very clear. These frequencies are common to several phenomena. Like atoms will have the same common frequency, and debris flow will have the same common frequency, and landslide will also have the same common frequency. So there is a possibility like we can display that by looking at the spectrum, we may display that some man-made noise, anthropogenic noise, may be treated as the landslide signature. To avoid that, we need a robust mechanism where we can automatically detect the landslide from the seismic continuous data. And these are the existing algorithms available in the literature, like SGY, short-term average to long-term average analysis, and statistical and cross correlation, and spectral ratio method. These are the methods available at present to identify the signal. It is not for the discrimination of the signal. Discrimination, I mean to say that, and we must be in a position to discriminate the signal source. That is, whether the signal is emitting from the earthquake, or from a landslide, or from a debris flow, or from man-made noise. This provision is not available in these all techniques. In cross-correlation, a second amount of possibility is there because there we will take some model waveform, we will cross-correlate with the continuous data, and if the correlation factor setting is somewhat higher, then we will find it out and we will match that with the template matching kind of thing, and we will decide that as a waveform from the landslide. So there is a need for the development of the detection and discrimination method to go ahead with the seismic monitoring technology for early warning system development. So for this purpose, we have collected the data all over the globe. Like you can see, we have taken the event from Alaska, Canada, Iceland, Greenland, Switzerland, Italy, Japan, China, and Taiwan. So we have collected all this data. This data is freely available online from the AGSEEN servers and accessible to everyone. And after collecting the data, we have in a windows of 5-minute chunks. And you can see here I have presented two signals, and which is a 35-minute signal where I have taken each 5-minute chunk before and after the event. Like you can see, 15 minutes before the event, this is gray color curve, is not at all matching. And when we compute like that, the green one appears as the odd one. Then similarly, I executed the experiment with the expected data also. Like a half-an-hour chunk, which is consisting a short duration of waveforms. And if you repeat this, I have seen these discrete trends of the landslide earthquake from the background noise patterns. And when we look at the same signal and compare them with the noise, you can see here, they are clearly discriminable from each other with above the error level. With error bound will be computed based on the randomness in the region. Here are please silent. Please silent. If you are not interested, you can go for the deep break. No issues. Okay? Yes. Don't mind, please. Yeah. If you take these PSD variations observed from these processes are clearly above the error limit. So from this we conclude that this can be used as a feature to identify the landslide signature in a continuous seismic data, which is even cost effective. I mean to say that completely it is not at all intensive because 1D spectral computation will take a few seconds. Like within 2 to 3 seconds in a normal computer, we can compute the spectrum of a single 1D trace. So the same way, we have also tested its statistical efficacy by means of computing its PSD skewness. When we compute the PSD skewness of the waveforms of earthquake and landslide, you can see here PSD skewness is varying. It was computed using 30 seconds window with 5 seconds overlap. So when we compute this with a continuous time varying matter, like in a moving window fashion, you can see this portion of the waveform is appeared in the window taken from here this time, as I have used the moving window with 30 seconds length, and it is occupied here, so that I can see a short change in the skewness of the PSD. Whereas when I looked at the skewness of the PSD of landslide, it's a gradual change. This also provided us with some information, like in addition to the comparison of the earthquakes and Marshall law is computed as a model for the global model for the landslide, earthquake, and the noise. We can also use this skewness as an additional feature. And from this study, it is very clear that this PSV will enable us to identify the landslide waveforms in the continuous and in the earthquake. And whereas when I compute the PSV is in a 5 minutes manner, you can see these are all noise. All are matching with each other. Whereas I can see two outliers. One is from the earthquake, the cyan color one, and other is the brown color one. This one is from the landslide. And this study has been this was published in Science, and we have developed one machine learning algorithm using these two features only, because there are several algorithms which are using the blind features. Like blind features, I mean to say that they will provide the data and they don't assign the feature which can be used. Like they will mention that statistical features. What statistical features the mission is using, we don't know. But out of all, it will give you some model with certain accuracy. Rather than that, after testing these two features, that one is the PS3 and another is the skewness of the PS3, we finalized these two features as the main features to the machine learning algorithm, which has given us a successful prediction rate of 98%. 98% is a globally high value as of now, because some of the other methods they have achieved 93%, and we are at the 98%. Okay. Yeah, I'm concluding this. Actually, these are the two examples from this is from the Indian data Uttarakhand, where we applied this technology. I mean, this technique on the continuous data from Uttarakhand. We have identified the landslide. Similarly, we have uploaded our method on a data set from Taiwan, where on the April 2nd there is a earthquake of 7+ magnitude in Taiwan. On that day, reports indicate that there are several landslides occurred in the vicinity of the earthquake zone, and there are several even aftershocks. And we applied this method and we have successfully identified 50 earthquakes from 2 days data, that is 48 hours data. Out of them, 28 were reported in the USGS catalog because they are big. And secondly, the small magnitude earthquakes, what we have recorded and identified in our analysis, we tested that they are clearly earthquakes only of small magnitude. And secondly, 9 landslides of the significant magnitude were identified from the same data. And finally, yes. These are conclusions like I'm sorry, actually I have a habit of using the color mic so that I am not able to hold it properly. So these are conclusions like spectral features would be they have a great advantage to discriminate the landslide cyclic waveforms in the continuous data. And in addition to the spectral features, we can also use the skewness of the PSV as another additional attribute which will enhance the, like when we use the PSV only, we have attained 96% accuracy in the machine learning model. But when we add the skewness of the PSV, the accuracy has increased to 98% in our modeling. And finally, this would be a great advancement of working towards the cyclic network-based landslide early warning systems. That's thank you for your
Can have one or two questions, please.
Yes.
Yeah. I'll go. Take it from next class. Mike, can make it. Ask some question.
So, by means of monitoring the continuous velocity change, using a transformation Thank you, sir.
Thank you, Raj sir. 10 minutes. Tea break for 10 minutes. We will assemble after 10 minutes here. Thank you.
సార్ అక్కడ అయితే మనకి కంప్లీట్ చేసి పేరు మారుస్తానమ్మా.
I request Dr. B.B. Mahalakshmi madam come on as an accept our coaching. Hand over my
Thank you. We have two papers and trying to ask Naresh Bhandari. Yes. Yes. Okay. And one more paper, assessing climate change impacts on oceanic dynamics in their Bengal. State. About time domain electromagnetic systems. Then data. Consent. Analysis of extreme rainfall events in the context of global warming. Okay, then now I am requesting Professor S.K.T. Krishna to start. Sir, it is 7 minutes. After 6 minutes, we have a. Thank you. You know that we follow that.
Good evening, everybody. I'm happy that all the students are here. This is an integration in what gravity, magnetic, physical properties, and how a geophysics can be replaced to derive a geological situation. But in fact, this work particularly done under a GST project, and mainly it is focusing the geological situations there, and wherever the geological problems are there, the discussions are there, whether this is right or that is not right. There are two different postulations, and our work clearly classified, clearly declared the real situation they are using the geophysics. And this is a gravity magnetic anomaly interpretation, understanding the magmatic processes and geological inferences on mesoprotolite gabbro anomaly complex near Chemotopti in Ongol, near Ongol it is. And the title geologically maybe different ages, you know, most for the sake of the students I am telling particularly. So different ages from Archean to the present scenario, different rocks are formed, how the rocks are formed, at what ages it is formed, at what age it was formed, how those are metamorphosed, and this information is really required for us to understand this. So one by one slides I will try to explain as simple as possible, particularly because of the students. And of course, this is my, I finished my MSc in State University in 1782, and we are all one family here. And my PhD in 1990 under the guidance of Professor Ivilaza Murtigaru, and worked in Institute of Geomagnetism for 2 years in Mumbai. Then joined SRM University, Nanded, Maharashtra as a lecturer, and then I retired as a professor in 2018, and worked another 3 years as an executive professor in the same university. And this is actually the geological scenario is there. And this is the entire area where the gabbro is one of the rock, particularly high density, and it gives the magnetic anomaly also. Wherever the red are there, these are the exposures of the gabbro in that area. And this is one area where different rocks are there. One is called the gabbro, other is called the nephrine cyanide. In between, ferrocyanide is there. And these are the geological exposures. Beneath the earth, what is there, we don't know. And particularly, we are first I will give you the entire information about the entire area, and then we will talk about this area where 3 different rocks are there: gabbro, ferrocyanide, and nephrine cyanide. What is the geological situation? Geological understanding is there. What our geophysics is telling. That I will try to explain by using the gravity, magnetic, anisotropic magnetic studies, and paleomagnetic studies. And this is the actual scenario. And the two different protons, what I'm telling you, the gabbro and the nepheline cyanates, those are formed at the same time, 1352 billion years back. These two protons are formed 1352 billion years back, and at the same pressure, 7 kilobars, and at the temperature, emplacement temperatures are different, 800 degrees and 1100 degrees, and at a depth of 20 meters, and these two are geologically two different magma setup. They come from the two different magma setup here, and the setup is co-spatial. Both are existing side by side and co-equal at the same time. The 1352 billion years is formed and not co-genetic. One is alkaline and another is covalent. And this is an unusual association. Generally, this kind of protons we don't get this kind of different magnetic with different magnetic association, different rocks occurring at the same place in the world. Only is there only 2-3 places, and one of them is in Mongol. And in between, this is the actually Chemurti, the gabbro. This is the gabbro program, and this is the nepheline cyanide program. This is the ferrocyanide. Within the gabbro, there are other rocks are there, glucogabbronite, and the granitic cyanopyroxenite is there, and the country rock is the amphibolite. And wherever we are using the geophysics, different rocks are there. What is important for this is what is the physical property differentiation is there. If physical property differentiation is there, we can use a particular method in that area and we can get the anomalies. The particular problem here is particular problem here is, I am telling that this ferrocyanide, geologically, geochemical studies, they have geochemical studies were there, and extensive geochemical studies say that this particular ferrocyanide is related to the gabbro. When gabbro is formed, along with the gabbro, this is formed. That is one argument. The argument is, no, this is not associated with the gabbro, this is associated with the nepheline cyanide. This is a geologically discussing problem. There are different postulations, different arguments are there, and we try to address that problem also using the geophysics. And this is the diversified petroleum. That's what I'm telling. This is whether it is the in between ferrocyanide is related to the gabbro or nepheline cyanide. That different people they argue in different way. So in this particular part, I'm talking about what's the petrography. Major element geochemistry, we use the data already explained, and the gravity studies, magnetic studies, paleomagnetic and anisotropy studies. I will try to explain as fast as possible that this is the physical property differentiations for different rocks, the densities, the magnetic susceptibilities are different for different rocks. So gravity and magnetic anomalies we can get, and we can use the gravity magnetic successfully to delineate this. This is only the pictorial representation of the physical property conservation. And in this area, along with the protons, the entire area, we took the gravity anomalies. From the gravity anomalies, we delineated the regional anomaly and the residual anomaly here. We got it here and we got a fault here. And this particular fault depth, the coinciding with that involved area, you might have known it, that is prone for the earthquakes. So it is not very high intensity earthquakes, regularly earthquakes are coming. Whatever the interpreted depth here is, the interpreted depth is coinciding with the depth occurred in the earthquake zone. So we delineated the fault depth extent. And the entire area, the Prakasam province, the gravity anomalies are interpreted, and at the gravity anomalies, the 3D modeling when we did independent bodies we are getting. That means beneath the surface, all these protons, bodies, whatever we discussed, is not connected, these are independent. So we are giving a geological information. What about the scenario beneath this? And this particular slide shows the gravity anomalies, particularly the gabbro, ferrocyanide, and the nepheline cyanide. And this is the three-dimensional modeling of this area, this area, and our studies reveal that geological exposure is only up to this place. And our study revealed that this proton is extending beneath the surface to further east, and it is not only extending. Our studies revealed that this is a tilted proton. So this is not like this. Slightly, it is tilted like this. So this information we got from our gravity anomalies. And this is the two-dimensional profile across the gabbro, ferrocyanate, and the nepheline cyanate. And this we interpreted, and particularly whenever there is the gradient difference is there, we try to delineate it. And this portion is ferrocyanate, and this portion is the gabbro, and this is the nepheline cyanate, and this is the glycopyrrole. So we try to get the independent bodies from the same gravity anomaly. And these are the magnetic anomalies in the same area, and the magnetic profile also will try to delineate the independent bodies of the gabbro, ferrocyanate, and nepheline cyanate. And this is the paleomagnetic ages. We collected the samples across all these rock types. The oriented samples we have to collect, and from the oriented samples, we conducted the paleomagnetic studies. And from the paleomagnetic studies, the ages, if you see, 1320, 1150, 1100, 1050, 1000. And this is the sequence of the ages we got for all these rocks. That means 1352 is the emplacement age in the first slide we have shown. We got from a paleomagnetic studies also around the same age, that is when the protons are formed. After that, these are some of the rocks are metamorphosed there. These are the metamorphic ages. And in the tectonic terms, there are different magmatic events are there, and these ages are coinciding with the magmatic events which are taken place in the area. And then the anisotrophic magnetic studies. The same oriental samples are the magnetic susceptibility, anisotrophic magnetic susceptibility. Magnetic susceptibility generally we conduct in only one direction. And anisotrophic magnetic sample will be oriented in different directions, and each direction the susceptibility will be calculated K1, K2, K3, three axes, and the ratios of the K1, K2, K3 axis talk about how the rocks are placed there in the area. And this anisotrophic studies are very important in the magnetic, in the magma flow characterization, how the magma is flowing, how it is characterized, we can get from this. And this is the area where we got nepheline cyanate, ferrocyanate, and gabbro. In all these areas, we collected the oriented samples, and K1, K2, K3, direction of the maximum susceptibility, intermediate susceptibility, and the direction of the minimum susceptibility. And this is the apparatus for the AMS, and we did these experiments in the Institute of Geomagnetism Laboratories, Mumbai. And these are the different directions. If we have 15 directions, the measurements will be taken. The averages in 3 directions will be calculated, K1, K2, K3. And this is to understand the magnetic fabric. Particularly, we have 3 different rocks: gabbro, nepheline cyanate, and ferrocyanate. Our problem is, already I told, geologically there are different arguments are there, whether ferrocyanate is related to the gabbro or ferrocyanate to the nepheline cyanate, related to the nepheline cyanate. And we will try to solve this problem. We will try to resolve this riddle of the geological riddle by using the geophysics. And here we used the stereographic plots, flint diagrams, Jellinek plots. These plots are by using the K1, K2, K3 values of the AMS values. And these are called the stereographic plots. And this is K1, K2, K3, 3 axes. But the distribution of the K, how it is there, and we talk about how the magma flow is there. And this is the nepheline cyanate, gabbro, and ferrocyanate. And these are the values. And if you closely look at the values, the lineation, foliation, degree of isotropy, shape parameter, susceptibility ranges, and susceptibility averages. These are the different parameters we are calculating from the AMS studies. Gabbro, if you see, gabbro lineation is 1.08, almost for ferrocyanate is also the same. But if you look at the nepheline cyanate, it is 1.06, almost same. Foliation, if you take 1.23, 1.23, gabbro and ferrocyanate it is same, for nepheline cyanate it is different. shape parameter also, gabbro and ferrocyanide is same, for nepheline it is different. Here like this, susceptibility range and average susceptibility also different from this. So, what the AMS studies revealed is that gabbro and ferrocyanide are showing same flow characteristics, and nepheline is showing a different characteristic. We try to use the gravity also to understand this, and these are the, you see the anomaly trends. The anomaly trend over the gabbro is like this, and if the ferrocyanide is also following the gabbro trends like this, whereas the nepheline trend is different. So from the gravity, from the AMS studies, and it shows that it is connected, the ferrocyanide are connected only to the gabbro, but not to the nepheline cyanide. Okay, yeah. And this is a theoretical gravity anomaly we prepared this. And as a conclusion, I told our understanding is how the magma, the protons are in place. The extension of the proton beneath the surface and the geological riddle, whether the ferrocyanide is related to the gabbro or ferrocyanide is related to the nepheline cyanide, it is clearly resolved in the AMS studies and the magnetic studies. So thank you, Ananda.
Only one person is there.
Thoughts are reactivated. Like the overburden or something. Why the shots are
Only two.
Actually, this area is a paleolithic. The area part is the paleolithic. So that's why the extensional tectonic activity causing the faults.
Extension activity is still going on.
No, it is failure. Now it is a small failure rate, now it is closing. Now earlier it is a failure rate, extension was there. Now it is a closing activity is going on. As I told in the age 1352,000.
It is local?
It is a local. It is a local. Yeah, it is not small block. It is 150 square kilometers area. In that area, the regular earthquakes are occurring only. Ongol. Like that, we get in Hyderabad also in the local area we used to get the Banjara Hills and the LB Nagar area, and near Vijayanagaram also in the local we get. In our area, in Nanded also we are getting the local part. Local phenomena is.
Professor, sorry.
Yeah. Thank you for that.
Okay. Thank you so much, Professor Krishna. Now I am inviting Sunata Ayam from IMD, investigating climatic and seismotectonic factors in Kerala's Wayanad landslide.
Yes.
Okay, 7 minutes. After that, you get there. Right? This one is better.
Good evening to all. So first of all, I want to thank our organizers for giving this opportunity. I'm Sunanda from IMT. I'm a scientist team. I'm presently working in satellite division, Delhi, New Delhi. Investigating climatic and seismotectonic factors in Kerala's 2024 Wayanad landslide. So landslides recently occurred in Kerala. What may be the reason? So that's what I want to see now. We'll go through. Natural hazards are natural events that threaten lives, property, and other assets. Often natural hazards can be predicted. Okay, landslides are triggered. So we all know what is natural hazards, and landslides are triggered by many factors. One in that is heavy precipitation, earthquakes, and human activities. So in this landslides, how far this heavy precipitation and earthquakes, is there any? That and all we are going to see. So present study, it is landslide occurred in July 30, 2024 in Wayanad in Kerala, the state. So objectives: to study meteorological parameters influence on a landslide disasters to occur, and then to study community-based mitigation strategies in landslide-prone areas, and then to study how seismic activity influence in this recent Wayanad landslide disaster. Here, what is the geological overview of Wayanad? If you see here, geological factors here. Wayanad group, garnet, selimanate, biotite, igneous, and peninsular gneiss complex. All these are present in Wayanad district of Kerala. Here, I want to show what are the how many types of landslides that are present. Here, slides type, flows, falls, and then topples. All these types of landslides are there, actually present. This landslides, not only in 2024 it has happened. In the beginning, 1960 also Kerala, Wayanad district is witnessed with these landslides. As well as in 2018, 2019 also, so many landslides were happened in Kerala. So in 2018, these are the landslide occurred areas. First, this is Idukki district. And Wayanad is somehow it is there. And in 2019, the number is increased. Many areas are witnessed this landslides and small landslides are happened. So this is landslide susceptibility. In 2019 itself, they monitored which areas are susceptible to landslide. So these are the areas. These are all Western Ghat areas. All these Ghat areas and high elevated area. The elevation is about 2,000 meters height. Elevated areas also observed. So those are landslide susceptibility areas. And these are the earthquake monitoring also started in this Kerala various districts. That is, this Idukki is more happened landslides, so that's why earthquake monitoring also more in this area. Then this is multi-hazard donation. So this area means where Kannur, Kozhikode, this area is highly elevated area. I said 2,000 meters high. So this area is more. All this red region is Western Ghat area, and this is more susceptible to landslide as well as multi-hazard. It's a landslide, it includes even flood also sometimes happening. This is a Wayanad district topography. So these are the high elevated, this is that is nothing but 2,000 meters high. So this is the land occupancy, like forest cover. All this it is indicating. Whatever what we are seeing, this is a land waste area is there, waste land area, and green part is forest area. And wherever we are seeing red region, that is building part in Wayanad district. And these are the satellite observations. At that time, what will be the reason? How far this rainfall is influencing? That I have taken care. Then from 29 July, Kerala has got extreme heavy rainfall, with more than 20 centimeters of rainfall. This rainfall occurred like 29 morning onwards. So if you observe satellite pictures hourly, half an hour we are getting. So if you observe all this patch, whole day it is staying over Kerala district. Here only our Wayanad district is there. So it received on that day 24 centimeters of extreme heavy rainfall, and these are the this is HEM product. It is also giving 24-hour rainfall over that area is as 28. Means this rainfall occurred from last 1 week. 1 week the Kerala state is received so much of rainfall, and in total rainfall as well as flood activity in that particular July month. So this pointed landslide occurred in July 13th. So even for this month, these districts got flood as well as these are extreme heavy rainfall events. If you see red part is extremely heavy rainfall that is more occurred in Kerala district. So causes using so topographic factors are playing major role here. Hills and mountains, steep slopes, thinning of soil. So if you continuous rains are there, means then even though the soil is very good, the thickness soil is there, but due to continuous extreme heavy rainfalls, the soil thickness is reduced and the rocky areas are exposed. So that caused landslide to occur. So here 50% of land area is under hills and mountainous regions, and then disruptive soil cover and changing nature of clouds. Of course, extreme heavy rainfall whenever it is there means a lot of soil residue, soil particles will go with the waters. So that's the reason. As well as here, if particular this week in Arabian Sea also there is a circulation. Whenever circulation is there, so then it influences a more amount of rainfall falling on that particular area. Climate change also playing a major role. Anthropogenic causes are this, we all know, widespread deforestation and culvert is all this are taking place in this particular areas. So this is the region where one landslide has happened. This is satellite picture. This is rainfall analysis taken last year's highest rainfall occurred these years in Kochi, Kozhikode, Kannur. So these this rainfall also influenced particularly in our Wayanad, and this particularly Wayanad district rainfall observed in that particular area. This is satellite rainfall, particularly in all this districts we have taken. In Wayanad also a good amount of rainfall. But how far, what is there any seismic activity that is also have gone? And these are the mitigation strategies. So, means in the rethink and added risk factors while constructing roads and culverts. So we should take care of whether that area is landslide susceptibility area is there or not. Like that we have to see. And these are the conclusions. 2024 Wayanad landslide during monsoon. Soil gets saturated due to percolation of rainwater, making it unstable, and so that leads to here slopes also greater than 20 degrees. That is the main cause. As well as meteorological analysis revealed offshore at mean sea level extending from South Gujarat to North Kerala. This is continued for 1 week. So that's the reason, one of the reason, and origin. High altitude difference amplified the debris flow impact causing significant damage. And then key contributing factors are steep slopes, then rock formations, and then soil type, clay-rich soils. All these are saturated with this heavy rainfall. As well as seismic activity, yes, minor earthquakes also occasionally destabilize this present slopes. And fully, I'll present my conclusions in my full length paper.
Thank you. Thank you so much. I have one question for you. Yeah, please. Basically, when you are talking about the landslide, have you conducted any process of stability analysis?
Sir, actually, this paper is I'm studying with seismic expertly.
You have done it?
Yes, sir. So once
it's good that you identified what are the causes and you have to map the weaker zones where possibly in the future that may occur. That will be more useful to the public.
Yes, sir. Yes, sir. We definitely.
We have mapped it.
Map also we will do, sir. We'll take analysis of that area.
Based on the
Seismic activity based on that.
Slope, seismic activity,
Yes, sir.
the soil type,
Yes.
all these parameters. Try to conclude that this area is more susceptible for land.
Yes, yes.
Thank you so much. Time, sir. Time constraint.
We will discuss.
Please, sir, please.
Problem is a land. Your figure shows that only place because of the grade, because it's not a land for life.
Okay.
Okay.
Thank you.
Thank you, madam.
Thank you so much, Sonata.
Thank you.
Excellent presentation. Now we have one presentation on 3D mock crystal structure of Astageta. Prahlad, assistant professor from Department of Geophysics, Andhra University. Prepare questions also from because it's my topic.
Good evening, everyone. Today my topic is 3D movement and cluster structure of the basalt pattern and analysis of the some gravity. So gravity analysis. So basically, the craton is one of the oldest craton. The lithosphere is very stable. When I was going for study in literature, I found hardly 2 or 3 papers. One is from Marita, another from Vitara and Manu. Hardly there are 2. There are 2. So therefore, we selected this particular reason. Next slide. Okay. So if you look at the region, it was surrounded by the red region as well as the violet region. So I have to choose. Therefore, I have to choose the particular region. Maybe what is the influence of these 2 mobile belts surrounding the star pattern as well as the Udane rift and as well as the Manu rift. So if you see, look at the elevation also showing the exact, the structure. Structure is maybe probably they are going to increase the pattern. So it is my gravity map. So this is the gravity map. I have shown there are many, highs and lows are, you can look at that. So lows are minus 81 milligram and highs are hardly 10. So these lows are attributed to be there are many proposed basins are presented for this particular region and it is hardly small. There are many basins study area. So and the basin is rich minerals and has been a center for mining and mineral exploration. Therefore, so my object is to determine the 3D moho topography as well as the process of the basalt pattern and the adjacent basins. So as well as we wanted to find some key interfaces of the study area like basement and conrod and moho interfaces. So for basement as well as conrod disconnect, we have selected one. There are 2 methodologies I have selected. One is spectral analysis, 2D radial spectral analysis. So for that, we have initially divided this study area into 181 blocks. So each block we have performed the spectral analysis. Each spectral analysis showing three discontinuities. So the red one is the highest one, the blue one is the middle one. This is the noise. This low spectrum showing the conrod discontinuity. This blue one is showing the basement discontinuity. Actually, the low resolution image. I'm very sure about this. This spectrum plots showing the basement as well as the conrod discontinuity. So next, and this is also the same story. And we have performed the entire area, the same analysis, and we got these basement test structures. If you look at the basement structure, this is the sigma basin. absolutely low. Hardly the maximum low is hardly it is 6 kilometer. And if you look at the basalt pattern, it is up to 26 kilometer. And there are the hardly, this is the Rift Basin, running the Godavari Rift Basin. This is the Mahanadi Rift Basin. And if you look at Sapura mobile well, and it is the high are reported from the mobile well. And now this is the contract discontinuity. So if you look at the contract discontinuity also, similar results were presented, but the depth of varies right from the 11 kilometers to 17 kilometers. The crustal structures are very difficult. High, low, which means somehow the structures are influenced by the adjacent structures maybe. So, and also we have derived the structure of the study area. For that we have before applying the spectral evidence, we have conducted a low pass the Bouguer anomaly to remove the high pass high anomaly of the Bouguer anomaly. So therefore we get only the low anomaly of the Bouguer anomaly. So we have applied Bouguer low pass 100 kilometer low pass anomaly. Perform all these spectral analysis. For that I have divided the Bouguer anomaly into 30 blocks. Each block has 2 degree, 2 degree, and also this is the final result of the Moho structure. So look at the Moho structure, the bomb. Here only you are getting 42 around 46 kilometers because this is the boundary of the basalt pattern and the mobile belt. This is clearly indicating the convergent boundary. So that therefore we are getting the high maximum thickness of the crust block. As well as, and this is indicating the Mahanadi Rift Basin, and these are the other part of the 3D area. And also similarly, we wanted to check once again for inversion, 3D inversion. The recently published by the PAM et al. 2022, he was generated the 3D inversion technique through MATLAB inversion. So we have applied the MATLAB inversion to our Bouguer anomaly. So that there are the equation I don't want to even explain about it. So that I will go directly the results. And this is the Bouguer anomaly of the my study area. And once when the map of the interface, as well as it will calculate the gravity anomaly, and it is going to it is a maximum RMS, what means the error. So we got excellent correlation between the RMS and IGSEEN. So if you give it the good conversions, then only you get the best output of the model. So and similarly, we have applied the same inversion method to 100 high pass 100 kilometer to the Bouguer anomaly. The same we will get the anomalies. So this is the result of the basement structure. We look at the basement structures showing the same. Maybe hardly it is 4 kilometer to 6.7 7 kilometer it is showing. So my conclusions are very simple. The basement rocks are varying right from the 4 kilometer to 7 kilometer. Andhra continuity varies from 16 to 22 kilometer. Moho varies from 40 to 44 kilometer. These results are best, very strongly correlate each other. Whatever we have applied the Bouguer pattern. So, I will happy get any.
Thank you, Prahlad. Any big questions from the students?
You have calculated the depth of the basement.
Yes, sir.
Have you removed the regional? Yes, sir. I have removed the regional. Well, that's so. Sir, in inversion, I have removed the regional, sir. In basement structure from spectral analysis, I didn't remove, sir. But I have applied the spectral analysis. From the spectral analysis, I have shown two rocks, sir. Yes, sir. These are the spectral clock, sir. So this is the low spectrum, sir. This is the high spectrum. From the low spectrum, you will get the contrast disconnect, the highest spectrum. Or else, if you go for very peak, you will get moho also, sir. But that moho mislead definitely. Therefore, we choose the this low, the standard. Is graded exposed there? Yes, sir. Yes, sir. Nice, sir. Arcane, nice, sir.
Around it.
Yes.
How do you get correction against?
It is corrected, Google corrected anomalies, sir.
Correct data.
Corrected anomalies.
You are communicating on this software. Not coming again with practice 4.7.
Yes, sir. We have applied only spectral data. So spectral analysis are only the resolution may be varied, sir. Yes, sir. Yes, sir.
Good presentation, Ella. Can you come back to your unit model? Okay. Fine.
Thank you, Prahlad. Anybody?
Any activities that come back, then we are ready to consider. Otherwise, we are taking the session.
I request Srinathara sir come to. I request Professor Gagan Madam Garu, please come onto the dais. One student also.
Forward, Alakshmi Madam Garu. Dr. Mahalakshmi Madam Garu, please come forward.
One by one open చేయండి 9 మోడల్ 9 ఇక్కడే ఉన్నాయి ఓకే ఉన్నారా కృష్ణమాచారి గారు వచ్చారండి కృష్ణమాచారి గారు వచ్చారా సార్ కృష్ణమాచారి గారు వెళ్ళిపోయారా అక్కడికి ప్రొఫెసర్ కృష్ణమాచార్య గారు బయట ఉన్నారేమో ఫోన్ చేద్దామా ఫోన్ నెంబర్ ఉంది సార్ ఫోన్ నెంబర్ ఉంటే ఒక్కసారి చేద్దాం కృష్ణమాచార్య గారు ఫోన్ నెంబర్ ఉందా చేద్దాం
కృష్ణమాచారి సార్ ఉన్నారు కృష్ణమాచారి సార్
సరే
I'd like to request Professor B. Venkateswara sir, please come on to the desk for chairman of the second call. And also I would like to request Professor Bagaman to felicitate Professor B. Venkateswara sir.
Actually, being an academic field, I've been continuously interacting with the department right from the beginning. And these gentlemen are recruited under
Under your guidance.
Madam, a little bit earlier. Yes, madam. 2006 she got recruited. The permanent faculty. Oh, the new vice chancellor has come. Most of you may be going. And mostly, I think at least 5 posts are going to be filled in this department. That is the indication. 5 posts.
You are wishing
God will save. We don't know or wish. So along with these people.
Yeah. That's good.
I think, thank you. Congratulations, madam. No.
Make it,
And also I request Dr. Mahalakshmi Madam to please forward as a co-chair.
Photo తీసుకోండి. Right, okay.
Oh, very good. Actually, Geophysics one.
Mahalakshmi. అవును మేడం సంబంధం లేదు బాబు. ఆ మేడం పేరేంటి? తప్పు చేస్తున్నారు కదా. కమ్యూనికేషన్ నేను పిలుస్తాను సార్. మీరు మేడం గారు అయిపోయిందండి. ఏంటండి బాబు, ఏంటండి? ఓకే చేశారు సార్. అవును సార్, నేను come by order. అలాంటప్పుడు ఎందుకు నేను పిలుస్తాను.
Request Dr. C.V. Rao sir, please come to the dais. I request Professor Rao sir, please honor the
Yes.
C.V. Rao sir.
So actually, Mr. C.V. Rao, Dr. C.V. Rao, he is my classmate, but in the year 78-81, he is an extraordinary candidate in our batch because very active here. And similarly, I know that he worked in ONGC, and there also very much interested this type of lectures to give. And immediately I called him when I was a professor here in this department of Geophysics. I called him, please take one class to our student and give some guidance. So that immediately he ran up from Mumbai to Visakhapatnam on his own caste. And given a good lecture to our students. real wonder. I appreciate your service, Mr. Dr. C.V. Rao. He is a great and immediately accepted my invitation and came over here to bless our students. It's a wonder. Once again, on behalf of our students and staff and everyone from our department, I appreciate him and congratulate him. Thank you very much.
Thank you, Dr. C.V. Rao, sir.
Thank you very much. And take this small gift mentor because we actually paid of this one session and full session, full session or something like that, and it also finished on time. On time. That's very important because yesterday we saw that the time is elapsed. Time is elapsed, no doubt at all. But it's okay. That's an inaugural function, everything is there. But there is no inaugural function or valid today. So, anyhow, he completed all the presentations in on time.
Including yesterday's presentation.
So, yeah. Thank you, Mr. Yeah. Thank you.
Thank you, sir. I request Dr. Mahesh Garu, please come on the dais. Scientist F, NRSC. I request Rina Rao, sir, madam, please.
So actually,
Scientist F, NRSC.
So as a young scientist, I am blessing because in future definitely we come to elevated position. Definitely get to elevated position, and this is a footstep for that. It's a footstep because you are acting as a coach. Acted as a coach here, and the wonder here is, and really on behalf of our student faculty, you are blessing because you are young, so therefore definitely reach your second goal. Thank you very much. Thank you very much. This is on memento on behalf of the department. Okay, thank you. Thank you very much, bro. ఇంకా చెప్పండి అయిపోయిందా ఓకే one more thing here I'll tell you. I forgot to tell you, Dr. B. Venkateswara Garu. I know him personally because I went there in Hyderabad. That is some JNTU. I met him and he appreciated my paper also at that time. I think he might be forgot it. He's a senior most, and of course he's junior to our batch. Okay, he's junior to our batch. Even then, he elevated a very nice position there in that university. It's a wonder because as an alumni, we should have to appreciate his service to the society. Really wonder, sir. Thank you very much, sir. Thank you so much. Thank you. Right, sir. Yeah, some are absent here. I think not absent. I think they went out. So tomorrow we'll see to felicitate him, Dr. Patro, Professor Chakravarti Garu, and Professor R.R. Rao Garu, and Professor S. Krishnamacharyalu. So tomorrow we'll see that we'll felicitate him. Right, sir? Thank you. If they left. Even then, don't bother about it because we'll send their mementos and whatever it is to our department to their address. That's our assurance I'm giving to them. Okay, we'll send to them. Right, sir? Thank you.
Thank you very much. And student, especially tomorrow there will be a IQ lecture talk. So please like student talk. Please be here 9 o'clock.
9 sharp 9 o'clock lecture will start.
All the students I am especially requesting you, please be here 9 o'clock. So So all of you, please.
One more thing here, please bear with your mind, students. So we have a comment. All the students are not present in attending the sessions. That's very, very important because these seminar is meant for you to learn, not for us. We already reached our goal, but this is the time to learn because so many important topics are here innovative topics. They are telling to the experts of this Geophysics field. Therefore, that is your duty. It's your duty to listen each and every presentation. Even though you have some works, you keep them aside, but come to that sessions wise and participate in it and enjoy the session. Is tomorrow will we meet here at 9 a.m.
That lecture will start by 9 o'clock.
Lecture is start by 9 a.m. IGU session. That's the plenary talk by
Lifetime achievement.
Sri Krishna is a famous. I think he worked as a scientist in National Institute of Oceanography and he was a Patnagar Award. The wonderful lecture we have tea and right? Please we'll meet here at 9 a.m. But before that you should reach here. Thank you, one and all. Right?
Thank you, all of you. Officially, we are concluding this session now. I think we have. We have a dinner. Students, we have dinner here.
What time sessions will
I think after tomorrow also we have presentations, natural resources. So my presentation also is there tomorrow. So dinner also is there. So dinner time. Dinner times. 7:30. 7:30.